It's gonna take 2 seconds for TikTok to go live because I didn't set it up properly like I usually do. So that's my fault, but it'll be ready in a second. All right, we should be all set to go. Howdy, howdy. All right, we are ready to go. Let me just start to get some things set up and we should be, yeah, okay. Okay. Here we are. All right. Didn't think I'd be live today. Why wouldn't I be live today? What? What? Why wouldn't I be live today? All right, let's bring up our first guest. Our first guest is Sober Squared. Let's see if that lives up to their name. I don't know why I can't talk. Let's see if they live up to their name. Sober Squared, how's it going? I don't know why I can't hear you. Oh, well, maybe I can't hear him.
Hey, hello, can you hear me now? Can you hear me?
I can absolutely hear you. How's it going?
Okay, sorry.
You're
All
good.
right, so I'm gonna be completely honest with you. I am not opposition, but I did have one question. I thought it was okay since you just started up.
All right, make it quick.
Okay. So I hold to the white hole theory, and then it falls into a false vacuum, and then it starts up quantum fluctuation and so on and so forth. I was wondering if that's a valid view, or if it doesn't add up.
I haven't seen any papers about it.
Oh, okay.
I'm not familiar if that's even like a thing that people take seriously. Maybe it is, maybe it's not, but I haven't seen it.
Okay. I just wanted to know if it was, because I thought if it worked for black holes we discovered mathematically, and if it works vice versa, then I wondered if it could be the case. You know what I mean? But, okay. I just wanted to get your opinion on it. Appreciate you, man.
Sorry. All right, let's bring up Sully. Sully, how's it going?
What's up, man?
Not a whole lot. Sully, what shape do you think the Earth is?
Oh, it's not a sphere. It's definitely flat, bro.
All right, why do you think so?
Measurements, microwaves, particularly. Microwaves are pretty compelling evidence. Can I ask you a, like, not a personal question, but not a non sequitur at the same time? Do you ever
Sure.
debate off of TikTok?
Like on like modern day debates or something like that?
Yeah, would you ever consider something like that?
I have before. It'd have to be I'd have a really compelling reason to do it just because I'm already so busy, as is.
Okay, I was just gonna put the offer out there, but we can move back onto the subject. So microwaves travel line of sight, right?
Well, they can, surely.
Yeah, they typically do. They're actually, according to NASA.
I mean, they also refract, right? Like all electromagnetic waves refract.
According to NASA, they're not affected by rain, sleet, snow, clouds, smoke. They're not really affected by that.
But you do understand that they're electromagnetic waves, so they refract?
Yeah, they're on the electromagnetic radiation spectrum, sure. Yeah.
Yeah, so they refract, they can reflect, like all electromagnetic waves.
So if we have world records of up to like 4,000 kilometers, right? And some that are even farther than that, but I couldn't actually, when I tried to trace the call signs to and fro, I couldn't really find like that you had to log in to get that information, so I couldn't access that. But I've gotten distances from like the coast of Hawaii, some island in Hawaii, I don't have all of those memorized, to all the way to California, which is about 2,500 miles.
Sure.
What would be a logical explanation for that, do you think?
Well, I mean, like, look, depending on the frequency, and microwaves and radio waves are similar, but depending on the frequency, you can have bouncing off the ionosphere, you can have atmospheric ducting. So, like, this is my view on microwaves, and generally on using electromagnetic waves, like light, to try to figure out where we are. I mean, like, flat earthers like to say that, you know, you can't look at the sky to figure out what the ground is. Well, I don't think that you can look at things that bend to figure out what shape the ground is either, right? So,
Well,
my general view is we should appeal to things that don't bend, that don't have these extra variables that can confound our experiments, right?
well, that's the dilemma that I'm having, is that I'm finding it difficult to believe that it would bend.
You don't think that
tropospheric
electromagnetic
ducting-
waves? You don't think that electromagnetic waves can interact, can refract, can reflect?
Well, the dilemma that I have, the dilemma that I have, right, is that if you look at like link planner or path loss,
I have no idea what that is.
when it's where they model these out mathematically. Okay, when they after the
Are these like websites, or are these like manuals? Like, what are they?
It's websites, right?
Okay.
You can actually there's actually like amateur websites where you can plot out your own microwave transmission before the fact, and what you do is you fluctuate the value of k, your coefficient of k, and that effectively.
You mean your coefficient of refraction?
Agreed. That is what it should be. Yes.
Sure.
But what it actually does in the mathematical model is it changes the radius of the Earth. They don't bend the light in the modeling.
Do you understand what k is doing in the equations?
It's alleged to be. It's funny because I have a whole PowerPoint put together because I get conflicting answers when I looked into. Like, did you understand? Would you admit, or are you aware that the value of k can be infinite?
It could be quite large. I've seen it measured up to like 10 or 15, but I don't know if it's ever been measured to be infinite.
Yeah, there's a formula that you use to derive it. You take your atmospheric refractive index, your n, and you divide it by your denominator would be the true radius value of the Earth, 6,371 kilometers. And if your refractive index is effectively 0, which sometimes it can be, you can't divide by 0, right?
So no, your refractive index can never be 0. Also, 0 divided by the radius wouldn't give you infinity. It would give you 0.
Maybe I do misunderstand, because it is something that I've been looking into for a couple weeks. But effectively, there is a value. If you even just Google k equals infinity, you get all kinds of information on it. It's very interesting stuff. And that effectively means that they make the radius value of the Earth infinite.
Making the radius value of the Earth infinite, according to the formula that you just gave me, would make the k value 0.
It would make it negative.
The coefficient of refraction divided by the radius of the Earth. If the radius of the Earth is infinite, then your coefficient of refraction, or then your that ratio is 0.
I would have to pull up the slides. I'd have to boot up my laptop and show you. So maybe we could do this on a different day. I can always come back because I don't want to take up all of your time. You're
I mean, so this is the thing that's measurable, right? Like, we can measure k.
We measure the atmospheric refractive index, yes.
Yeah. And so it can be quite large. Like, I'm
There's
looking at
a formula for that. It's like 0.776.
I'm not talking about a formula. I'm talking about just making direct measurements. I'm looking at a table right here that has direct measurements of the index, or of the coefficient of refraction, and it peaks at like 15 in this graph.
Well, are you looking at big K or little k?
It's the coefficient of refraction. I don't know what convention you're using for the naming.
There's one for like standard refraction that we use in like plane surveying, and there's another that we use, which is a small k, not capitalized.
1 second.
And we use it for microwave waves. Yeah.
1 sec.
And that value can go up to
so this is for optical refraction, to be clear. So we're talking visible wavelengths of light. We're not talking microwaves. But
no, we're talking non-visible.
But no. I mean the one that I'm telling you about. But to be clear, the phenomenon is the same. Right? It's electromagnetic waves. Electromagnetic waves bend when the medium is changing its index of refraction.
This is the dilemma that I have, right? Is that it is claimed to be a refractive index bending the light, the transmission, right? But when they model it out in path loss, they don't bend the transmission around. Like you would agree that it's the radius value of the globe would always consistently be 6,371 kilometers.
Sure, whatever
minus
the number is.
Sort for the semantics. I understand it's not a perfect sphere, right?
Whatever the number is, about 4,000-ish miles, right?
Yeah, but they use the metric system for this.
I understand.
Yes, absolutely. So that would be your constant, right? So when they fluctuate the value of K, that should always be you're fluctuating the refractive index, not really fluctuating it, but measuring it and then incorporating that and bending the frequency around a constant of 6371. But when they model it out mathematically, and I can link you to sources that show this.
And no, look,
they don't
I believe
actually
you.
do that.
It's because,
Please don't interrupt me.
It's because, well, I'm answering because I know what you're saying. The point is that
But they
there's two ways
the
that you
Earth.
can model this,
They flatten
right?
the Earth underneath of it, sir.
There's two ways that you can model this. You could either solve a very complicated differential equation, which would involve a changing angle. Sorry,
take the derivative of
which would
n
involve
and
the
divide it by the derivative of z.
That's not the complicated angle, the complicated differential equation that I'm talking about. You could either take a complicated differential equation around a curved Earth and use the changing index of refraction of the air around the curved Earth, or you can just, and you can check that these two things are going to be formally equivalent, mathematically equivalent, or you can set the index of refraction to be constant and just treat the Earth as larger. And those are going to give you the same answer. It's just one is much more numerically challenging.
Do you see how that doesn't exactly build confidence in someone who's trying to find
does.
out?
You just actually have to look into the mathematics here, right?
I have. I've looked into the mathematics quite thoroughly, and yes, they do use calculus.
Can you detail what differential equation you would have to use to solve for the path of a light? Sorry, the path of a ray, like an electromagnetic beam, on a curved surface with a constantly changing angle of refraction?
Yeah, you would take
a complicated calculation.
You would take the derivative of pressure and temperature, respectively, output over input, and compare that to the elevation, right? You take a derivative of z.
Right, and then you need to map that onto spherical coordinates.
You only have like one extra variable.
Then you have to map that onto a spherical coordinate system. And that's tricky,
exactly.
because solving those differential equations, especially if they're second order nonlinear differential equations, they can be really complicated.
So they take it from a hyperbolic coordinate system and they change it into a Euclidean system? Well, it's still non-Euclidean, or it's still Cartesian, right?
No, not necessarily. Not if they're using spherical coordinates, or in this case, polar coordinates.
Well, we map it out using Euclidean and 3D Cartesian. Yeah.
So it looks, and actually, this is actually a good point, because when you have what's the correct word here? There are certain differential operators that show up and they have different representations in different coordinate systems. In Cartesian coordinate systems, Laplacian operators, certain differential operators are particularly simple because the coordinate system doesn't change as you move from place to place. It doesn't turn, it doesn't bend. However, if you take that same differential operator and you try to use that differential operator on a curved surface, or rather in a curved coordinate system, like in polar coordinates, spherical coordinates, whatever it might be, that differential operator can become a lot more complicated, which is why one of the things that you learn when you're taking a class in differential equations is you learn certain coordinate transformations that can make solving the differential equation easier. So
I completely agree.
The way that we take measurements, the way that we evaluate things the way that we take data often is using Cartesian coordinates. You're right, because we live in this three-dimensional world and it's just a convenient set of coordinate systems. However, if you want to then solve for a trajectory on a curved surface, which is allegedly what we live on, you have to take that data, coordinate transform it, and then solve a complicated differential equation across the surface of a circle in this case. My point is that there's two ways you can do this. You can either solve the complicated differential equation, or you can get the exact same answer out just by treating the differential equation as an algebraic equation, which is what happens if you treat the coefficient of refraction as constant, the coefficient of the refractive index as constant, and then just treat the Earth as larger. They will give you the same answer. One is significantly more numerically expensive than the other.
Numerically expensive. It's literally one extra.
That's solving the differential equation.
I let you finish, sir. I let you finish. So it's not actually that much more complicated. It's an additional variable, right? It's actually not that much more complicated. And if this is as concrete as I believe it to be, it doesn't, like I said, it doesn't exactly inspire confidence when we quite literally extend the radius value of the Earth theoretically in concept to be infinite in value. And if you would agree with me here, if you have a sphere with an infinite radius value, it can't exactly be a sphere anymore now, can it? Because it's not even any shape, really. But the surface of that shape would objectively be flat. So they do flatten out the Earth. Even when they incorporate 4/3.
What?
Yeah. Even when they incorporate 4/3, like standard refraction, what they claim to be standard refraction, 1.33, they still flatten the Earth underneath the transmission.
When you say flatten, it doesn't make it flat. It makes it bigger radius.
It makes it
That's
flatter.
what you mean. Yeah. So
It makes it
to be
flatter.
clear, are you familiar with solving differential equations? Like, is this something that you are?
To some extent, yeah.
So, would you be able to write down what the differential equation is for a electromagnetic wave on a curved surface?
No, not with electromagnetism. No, not necessarily.
Which is what a microwave is. So you have an electromagnetic wave
would-
on a
it
curved
wouldn't
surface with a
be-
changing
but
index of
This is the
refraction.
problem that I have is that I'm no expert, right? But these people are alleged to be experts. So why are we simplifying just for the sake of simplicity's sake?
Because you
right?
get the same answer. Why would you bother
But you
solving
don't,
a harder
though.
problem when you can get the same
you get
answer?
a radius value that is infinite, sir. That is not the same answer.
Look, the answer that you're trying to solve for when you're doing these kinds of calculations is like, where is the microwave going to end up when I go this far away? That's the answer. The answer is not the radius of curvature. That's used as an input so that you can get the answer correct for when you want to figure out where the microwave will end up 600 kilometers away. That's the point. Right?
Okay.
You're not actually, like, we're not saying the
We're
radius is
talking
actually
25
changing.
2,500 miles.
I know, I was just giving you an
600
example. We're not saying the radius isn't actually changing, right?
agree.
What's happening is that you are modifying your model so that you can capture a complicated feature with a simpler feature. Does that make sense?
Okay, so can I give you a thought experiment, right? Like if you have a location, like from Hawaii to California, where we had to make the radius value of because in cases of tropospheric ducting, they always use k equals infinity. This is objective, right? They always
I mean, I've
they
never
always
heard that
extend the
claim,
radius
but
of the
I'm
Earth
also
to
not a
be
microwave
effectively
technician.
infinite. Don't. That is objectively true. If you do a little bit of research into it, you will find that. Yes. That is objectively true. And then if you have one location from California to Hawaii where tropospheric ducting is used, and k equals infinity there, and then you have another location like outside of Perth to Australia, right? Like then you have another location where the radius value is infinite. Your model's not exactly a sphere anymore. Does that make sense?
No, I mean, it is still a sphere. As long as you have a
Especially not with a
as long as you have a
constant
non-infinite
6371.
radius. And by the way, I'm not actually seeing that they use an infinite coefficient of refraction. I'm not seeing that anywhere.
I tell you what, bro. If I had my laptop, it's at like 30%. I don't feel like booting it up. It's gonna die.
That's
it won't
fine.
die.
That's fine.
Do you have time?
We don't. I mean, we don't have to go over that now.
Do
So
you have
look,
time? I will show you if you have time.
I mean,
do you have time?
I don't have like 2 hours, but if I have some time, I have like 10 minutes. But I don't know how long it'll take. The point is we don't like. I can just grant you that this is contentious.
For you, bro.
I can just grant you that this is contentious, right? That there is apparently some sort of contention between flat earthers and globe earthers here. So what we could do is, instead of using things where, like, clearly electromagnetic waves are things that bend and like they do refract, this is something that's well understood. And the question is, how much do they refract and what kind of effect does that have? Instead of using electromagnetic waves, why don't we just use something that doesn't refract to try to figure out the shape of the Earth? That seems like a way of eliminating this extra variable, which is causing contention.
Well, see, according to NASA, these things don't even tend to refract. That was my original argument.
It's obviously the case that all electromagnetic waves refract. This is like well understood physics. It's been well understood for 150 years.
There's a possibility, but when you're highly focused at like
I don't know
maybe, like,
which NASA you're talking
on a wavelength of like 10 centimeters.
Crazy claim.
I can show you. With a wavelength of like 10 centimeters on such a highly focused, potent beam of electromagnetic radiation traveling in a straight path, it's not going to tend to refract. Here, I have the source right here. Microwaves penetrate haze, light rain, snow, clouds, and smoke. This is from science.nasa.gov/EMS.
Doesn't say anything about not refracting.
Okay. Unlike lower frequency radio waves, they cannot pass around hills, meaning they cannot diffract. They cannot pass around hills or mountains and are not refracted or reflected.
Diffraction is not the same thing as refraction. Go ahead, continue.
See, you're not letting me finish now. They are not refracted or reflected by atmospheric layers.
Okay, so they don't have to be refracted by atmospheric layers, but they can still refract, right? Like if I just Google,
But it has to
do
reach its
microwaves,
depth- it has to reach
do
its
microwaves
destination
refract? The answer will be obviously yes. Yes,
Do you want to
microwaves
see the
do
k
refract.
equals infinity stuff?
I mean, do you agree that this is contentious?
Do you want to see the k equals infinity stuff?
I
where
mean,
they
sure if you
incorporated
want, but
tropospheric
I mean, the
ducting?
point is this is going to be contentious, right?
I mean, it feels like you don't want to talk about it. That's what it feels like.
Well, I mean, look, there's clearly like a gap in the understanding, that's perhaps going both ways. Like, I don't know a lot about microwaves. I'm not a microwave technician. I do know a lot about like electromagnetism. So like, there's clearly like a gap that there's causing some contention here. So instead of talking about something that is contentious,
I'm trying to dissolve that. I'm trying to dissolve that and just source my claims.
Okay,
so if you
sure.
Can big box me, I'd
I
appreciate
can't
it.
big box you. You're on 4 platforms, and it won't show up on all platforms.
Okay, well,
you can give me the source though.
You're not going to be able to. You're not going to be able to read it.
Can you give me the source?
An accepted way to model this
up?
phenomena is to.
Like, where can I find it?
It's a long one. westernstatesforum.org/documents/2006/2006.
Wait, hold on. westernstatesforums.org.
It's a PDF.
That's fine. /2006/
/documents/2006.
So Western States Forums
again.
/documents/2006/ yeah, sure.
/2006/2006. There's 2 2006s.
Yep.
And then a percent symbol 20 WSRTTIF. Forgive them, band of micro motorcycle people.
WSRTTIF.
WSRTTIF percent 20 TURNBU.
Sorry, your audio's cutting out. TURN what? You there?
TURNELL.
TURNELL.pdf.
BULL.pdf.
Sorry, your audio is just cutting in and out.
Big boxing me would make this so much simpler. I know you're more worried about what the audience can see, but I'm more worried about what you can see.
Literally, you're on 4 platforms. It'll like break all of the live streams.
Okay.
So
well, can I just read it to you?
So it's 20.
An accepted way to model this phenomenon is to use a coefficient of k that modifies the mean radius of the Earth.
It's percent.
Why does it do that?
It's percent 20 TURBULL.pdf.
How about I just?
I don't know why I can't just.
I mean, I feel like there's got to be.
Go over this with me.
Listen, just hear me out.
I'm
going to, but I feel like
/documents/2006/2006 percent 20 WSRTTIF percent 20 TURBULL.pdf. Is that correct?
TURNBULL.
Okay.
You only made one typo. That's really good, actually. Congratulations.
Saying that the site can't be reached.
That's actually really cool.
westernstatesforums.org.
It's a PDF, bro.
I know.
It's
I
a
understand
PDF.
That. I
You're not
understand
going to reach it.
Is it accessible on the internet? If so, I can reach it.
Well, I will send it to you. How about that?
Okay. Yeah, sure. That's fine.
Okay. And I'd like to read something that I found on this, and I can give you a different source if you'd like to verify a secondary source.
The reason why I want to take a look at this is because like I don't know this source. Like, what is Western States Forums? Is it like a reputable source? Is this just like a slideshow put together by some rando? Like, that's the question. And so I'd like to take a look at the source.
What about urgentcom.com?
I have no idea what that is.
Urgentcommunications.com.
I have no idea what that is.
What about evansolutions.com?
Do we have any scientific studies or EDU sources or anything like that?
This is the efficacy of how microwave transmissions work. This is the efficacy of what you will find if you just Google k = infinity.
Okay,
you will find
Google
so
k
many
=
different
infinity.
things on this.
Okay, just Google k = infinity.
Microwaves.
Okay. So I see microwaves 101.
That may or may not be it.
So
the
back
name
in
of
2006,
the PDF,
we contacted.
Here.
So apparently the stability factor is capital K.
Planning a microwave link. It's not just line of sight. Try that.
Okay. Planning a microwave link. It's not just line of sight. Sure.
There's a semicolon in there, but I doubt you'll.
Yeah, that's fine. Okay, so this is from Evans Engineering Solutions. So this is like a guy. I don't even know what P.E is, but that's fine. He's giving okay, so this is some sort of engineering thing. So he says, hold on, I'm just gonna pull it up for both of us, okay? So we can look at it together. Can we see it? So this is what we're looking at?
You're gonna want to go to page 11.
But this is the document, right?
Yes, you're going to want to go to page 11.
So I'm just going to scroll through if that's okay. So we have some theory, making sure you have a clear zone, accounting for propagating conditions, setting your fade margin, adding up against blah, 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 blah. Okay, so type of radio wavelengths. I'm sorry. What does that say?
It's a satellite, looks like.
What's that right there?
Yeah, that's a cartoon. Why don't you scroll down to page 11?
So why does your own document say that these waves can be refracted?
Hold on. Wait.
You're cutting out again.
Are we debating there?
You're cutting out again.
Are we debating that?
Bro, I'm gonna turn off your video. Hopefully the connection will be a little bit better. One more time.
Accuracy of K.
This isn't just me, right? Chat, you guys can confirm.
Yeah, your microphone probably isn't the best.
Okay, it's not just me. Chat can confirm that your audio is like cutting in and out really, really bad. I can't understand anything that you're saying. I got nothing. I don't know what you're saying. He hit his lag switch. That's so funny though.
Alright.
Can you turn your Wi-Fi back on? Plug your Ethernet cable back in? That was real convenient timing. I'm actually curious what it says through the rest of it. Consider a signal from a transmit point to receive point. Okay, so there's some free space path loss. Okay. For Fresnel clearance of a microwave link, we consider the calculated first Fresnel zone. Fresnel zone is basically the region, if I remember correctly, it's the region in which, oh, he left. It's a bummer. The path in Fresnel zone should be plotted on a terrain profile graph with Earth curvature. Huh. What? Why would we do that? Oh, he's back.
What does it say on page 11?
Look, we're going to scroll through the whole thing and read it. So we have Earth curvature here, which is interesting. What is this K factor in path studies about? The K factor takes into account the refractivity in the atmosphere, which bends the beam either up or down. It is the effective Earth radius divided by the true Earth radius. In effect, the bending of the beam up or down makes it appear as though the radius of the Earth is less than or greater than the true Earth. A K factor greater than 1 means the beam is bent towards the Earth. Less than 1 means the beam is bent upwards. K factor considerations. For K greater than 1, the radio horizon is longer than the optical horizon, which allows shorter towers. K factor of 4/3 is used in most cases for planning a link. In wet coastal areas, however, K can be as low as 0.5. Lower K requires higher antennas. Interesting. I didn't know a lot of this stuff, so I appreciate you bringing this up. Going back to our STL path with K equals 4/3, okay, we have a new path with the curvature of the Earth included. Path is redrawn for K equals 1, true Earth radius. So we have more curvature and less curvature, I suppose. And so I guess the point is that you can get, like, you have to, you aim higher, so that's interesting. Now plotted for K equals infinity.
They would never use
flat Earth. Okay, yeah. So here we have a flat Earth.
What does that say after that?
It says flat Earth. K equals infinity flat Earth. It's also possible to plot microwave link in Google Earth.
Can I say something? Or are you gonna like monologue through this and act like you don't understand
wait, you wanted me to read it. So we have flat Earth, we have true Earth radius, and we have K equals 4/3.
I'd like to, this is you becoming extremely uncomfortable in front of an audience of 700 people, bro.
I'm actually wildly comfortable because this is crazy.
Outside of, yeah, great, a cartoon. When we model that out in reality,
do you think that refracted waves don't happen? Do refracted waves, do microwaves refract or no?
We have to change the value of K to model that out in reality. We have to change the value of K to model that out in reality.
So why did you say that most of the time they use K equals infinity?
What's 4/3? What's 4/3, Blitz? We talked about that earlier.
1.33 repeating. It's a number.
Yeah, so you would divide 4 or 3 by 4, right?
No, you divide 4 by 3.
4 by 3, right? 4 by 3. I spoke it right the first time. So that would be your assumed Earth radius divided by your
the true Earth radius. Yeah.
Right.
as a result
So
of
they
refraction.
changed the value, which gives you 1.33 of the actual radius value of the Earth. So they do not keep the Earth radius constant. They never use K equals 1.
It tells us what K is. K is
Yeah,
the
they never use K
K
equals
uses
1.
the effective
You can't
Earth
use
radius.
K equals 1 because that would assume there is. Yeah.
It's not.
I know. I explained that to you before you asked me to source it.
It's not the physical
Bro,
radius.
you act like you didn't
right?
learn all of this from me before you brought up the document. Now you're learning.
I mean,
Calm down.
this guy better explained it than you did, I guess. So, what does the K factor say? It takes into account the refractivity in the
where
atmosphere,
I got all the information
which bends
from.
the beam either
Not all
up
of
or
it,
down.
actually.
So, wait a minute. Actually, I'm kind of curious. Why would they ever use K lower than 1? If
There's
the Earth
a
is
thing
flat?
called okay, there's a thing called sub. I haven't actually. They would use 2/3.
Well,
For
this
cases
guy
like
says
that,
as
they would
low
use
as
2/3.
0.5, which is smaller than 2/3.
Oh, so somebody in your comments knows it better than us. Okay.
No,
Oh,
I'm looking at the. this isn't from the comments. This is
I've
from
never
the
seen
document
that, but I've seen 2/3.
This is the document that you
Okay,
told
so
me
if you don't
about.
have,
How
if
have you
you
never
ask me a
seen
question
this?
and not let me finish it, are you really winning?
How have you never seen this?
If you,
It's in the
if you
document
ask me
that
a
you
question
told me to
and not
look
let me
up.
finish. No, I've never seen that. Dude, are you gonna give me a chance to speak?
Go ahead, please. Explain
I've
why
never
your
seen that
document says
actually
this.
be used.
Okay. Are you a microwave technician?
I've never seen it actually be used. I've never seen it actually be used.
Are you a microwave technician?
They use 2/3, which would not be 0.5. What would 2/3 be, Blitz? It would be 66, right?
It's 0.6, 0.66 repeating. Yeah. Are you a microwave technician?
Yeah, so it's not
You are-
0.5.
I'm sorry,
Oh,
are you a
okay.
microwave technician?
So in the actual
Are you a microwave
efficacy
technician?
of using these, I thought, are the actual efficacy
I
of
can just turn
using
you
these,
down
they
if you're
would
not
use
gonna
as
answer
low
me.
as 2/3 from what I've.
Are you a
from what I've
microwave
read,
technician?
Right.
Are you a microwave
So
technician?
it appeal to credentials automatically? Are you losing that
No,
bad?
I'm not appealing to credentials. Just answer the question.
Are you losing that bad? All of this that I had to teach you when you asked me for my credentials?
This isn't an appeal to credentials. I'm asking you because you said
Do you
that
want a
you've
secondary
never
source?
seen this done. Now, I'm asking what you mean by see this
I've
done.
never
If you're a
seen
microwave
0.05.
technician,
I've never seen
if you're
0.5. No.
if you were
I've never actually look.
what do you
I
mean
looked into,
seen?
Listen to me,
What do you
bro.
mean seen? Did you actually go out and like
Listen,
see
I
how the
will
calculations were
explain it
done,
to you.
or are you just looking up
Yeah,
like
you can't
the
ask
documents,
me a question
right?
and then monologue through it, bro.
You
Relax.
actually have to answer some questions sometimes.
Listen, let
Is
me
that
explain.
fair? Yeah, go ahead, please.
I'm trying to. You're not allowing me to. All right. It's so crazy, bro. You're actually getting cooked so hard.
Oh, this is so embarrassing
if
for
you
you.
look into the different formulas that they use, and I will source you different formulas that they use. I've never seen 0.05 be used in any of the specific transmission links that I've looked into. I've seen 2/3, I've seen 4/3, I've seen infinity, and I've never seen 1, right? Because you can't actually use 1. You can't use the true Earth radius value because we do have an atmosphere.
Now I have a question.
That's what the claim is. So they can't actually model it out. Was this all for modeling? You understand that,
Now
right?
I have a question, Sully. So, what do you
This
think?
is all for modeling, right?
Sully question. So, what do you think is what are the conditions? And clearly, you know about this. What are the conditions in which you would use 2/3?
If it was refracting upwards, I'd imagine you'd have to have low pressure and on the underneath, and then like high pressure above.
Okay, and
That
what are
would
the conditions where
probably
you would
be
use
what causes
4/3?
it. The opposite.
Okay. Now, is there a smooth gradient between low pressure above and high pressure below, and vice versa? Is that a smooth gradient?
All you're doing is giving credence to me not seeing 0.5 visible in reality, because we
Why
do
are
have
you
a pressure
avoiding the
gradient.
question?
No, I'm answering your question. You answered your own question.
No,
That's
it was
the
a yes-
problem.
it was a yes or no
you
question.
You don't see 0.5 in reality because the pressure
I'm not
gradient
getting at
decreases
that.
as you go up.
I'm not getting at that. I'm asking you a question. Is it the case that there's a smooth transition between high pressure here and low pressure here, and vice versa?
Typically, yeah.
Okay. So if there's a smooth transition, and it's that pressure gradient, according to you, if it's that pressure gradient that causes this, and there's a smooth transition in the pressure gradient, the intermediate value theorem from calculus would indicate that the K value, there is some atmospheric conditions where the K value is exactly 1, where that's what you would use.
I've never seen K equals 1 be used.
Okay, but you understand that if there are conditions where K is less than 1 is used, and there are conditions where K is greater than 1 is used, then the conditions between
I've never
those
seen
two.
a condition where k equals less than one be used
I'm just asking you to think logically here, right? If we know that there are conditions where k is less
Give
than
me
1
an
is used,
example of k equals less than 1.
please
Give
use
me an
your
example
noodle.
of it.
Use your noodle. Wait, you've already given me an example of where k is less than 1.
Yeah, that doesn't happen in reality.
Wait, you don't think that they ever use k is less than 1 in reality? Didn't you just cite an example?
No.
Wait, you said that you've seen them use k is 2/3. That's less than 1.
No, I've
did you
seen
just
them
cook yourself?
state that it is viable
Yeah,
for intents and purposes
right.
in
So we're
modeling.
talking
they don't
about
use it in
modeling.
reality.
I don't
You're never
know.
gonna. Okay,
What
so
do you,
this is where you have to
What
let
do you
me
mean they
speak.
don't use it
You
in
have-
reality?
no.
We're talking about modeling.
You have to
Modeling
let me
and
speak,
reality
bro.
are like you
let me
use
speak.
numbers and model.
You have to let me
You have to
speak.
actually listen sometimes.
You have
Okay.
to let me speak.
You have to
have
actually
to let me
listen.
speak.
I'm
Please let
not.
me speak.
I'm actually going to address what you said.
I have to listen to you. You can't ask me a million questions and then not let me answer any of them.
Okay, I'll just turn you down. I'll just turn it down instead. So look, the point is that you don't use numbers to make measurements about reality. You use numbers to model reality. So of course you're not going to see k is less than 1 in reality. You're only going to see it in modeling because that's where the numbers are used. Numbers are used in modeling. So you've already agreed that you use k is less than 1 in modeling. You use k is greater than 1 in modeling for different atmospheric conditions. And so there will be some atmospheric conditions where you would model that with k equals 1, and that follows directly from the intermediate value theorem of calculus. Go ahead.
Can I speak now?
I did just say go ahead, did I not?
Okay, cool. I couldn't hear you. So, in modeling, yeah, but remember that the refractive index is supposed to be the value of k, and that they don't actually change the refractive index when they model it out. They change the radius value of the Earth. They flatten it out, and sometimes they even bend it up, depending on how it actually. But I've never actually seen that be used. But they can actually bend the radius value to make it convex. Or concave rather, concave.
So just to be clear,
that is literally what k does. It changes the it changes the radius value of the Earth.
Yeah, it's to
in
make
modeling.
them. Yeah, exactly.
So in reality, this is where you have to interrupt me, right? But in reality, microwaves travel in a straight path. We model them in a straight path. We flatten the Earth underneath of it. That every single time we have to flatten the Earth underneath of it, regardless of what modeling mumbo jumbo mathematical nonsense we have to do. Doesn't matter what the would you agree that you just got cooked, bro? Please,
no,
instead
this
of
is
trying
hilarious.
to turn this around on me.
It's crazy to me that you think that this actually demonstrates that that microwaves don't bend, that they don't refract, because if you use any k value that's not infinity, that implies bending. And you've already agreed that modeling is used where k is not infinity. You use k values of 4/3 and 2/3 according to you.
Infinity is used.
According to you.
Infinity is used.
I don't care how frequently it's used. Please don't interrupt. They do use 2/3 and they do use 4/3 according to you, which means that it must bend because the Earth, even if the Earth is slightly larger, or even if the Earth is slightly smaller, you said those things. You said that they use that in modeling, which is what we're talking about here. They're trying to model a real world
thing.
This
is where you have to let me finish, because you're misrepresenting me.
You were interrupting me in the middle of my sentence. You're accusing me of not letting you finish. I'm sorry. Please try again. So the point is that if there is any
You're misrepresenting my argument.
Okay, then you can correct me when I'm done. If there is any k that accurately represents the world around us that's not k equals infinity, that implies that there is some degree of bending. Go ahead.
Okay. In modeling, they use anything from what I've seen from 2/3 to 4/3 to infinity. They never use 1, which would be what you would use, because they claim that 1 is when it bends perfectly around the Earth. Even though that what you claim is happening, they don't actually use it. It follows the true curvature of the Earth. 1 is when it follows the true curvature of the Earth. Yes.
No. That's not when it follows the curvature of the Earth. That's when it travels in a straight line, and the Earth and it doesn't bend at all, and the Earth is just curved underneath it.
1 would be representative. What's 1 divided by 6371?
It's 1 divided by 6371. It'd be some tiny number.
Yeah. It'd be
what
negligible.
Do you mean, yeah? Right? Wait, do you understand that? The algebra that's happening here?
Okay.
Like, if you take k as equal to 1, that means the effective Earth radius is equal to the true Earth radius.
Yes.
Do you understand that? Which means that in that case, the light would just travel straight, and the microwaves would just travel straight, and the Earth would curve underneath it. And it wouldn't follow the curvature of the Earth if k equals 1. You understand that?
One is attributed to a true Earth radius, right?
When k equals 1, the effective Earth radius and the true Earth radius are the same.
That's
what it means when k is 1.
So that would mean that if it were to travel,
go ahead.
It would follow the, if it were to, okay, so if you have a transmitter and a receiver 100 miles apart, okay, you transmit a link, and those connect, okay, and you have a k factor of 1, that means that it followed the true curvature of the Earth.
No.
That is what should be used 100% of the time.
That's not what k equals 1 means, no. I mean, we can go look at the plot, right?
Okay.
So like,
now it's not.
So look at the plot. So here in green.
Wait, scroll back up.
Yeah, here.
K equals 1. No, down.
Yeah. Here? Yeah.
To the diagram, right there. True Earth radius. Wow.
Yeah. So let's look. Hold on. So here we have, if we emit at say 2500, and then we have straight line trajectory, right? That's the green. Green is a straight line. It's just the path of light taking a straight line, not just taking a straight line as if there's no refraction at all. Then the final position is 20 meters higher than the initial position. That would not be following the curvature of the Earth. That would be going straight while the Earth curves below it, therefore ending up at a higher altitude. This seems like it's backfiring for you. Because I just don't think that you understand, like,
when they model
electromagnetic waves here.
Literally flatten the Earth, bro. That is literally the argument. When they model it out, they flatten the Earth.
I understand that, and that's because microwaves will bend down in some scenarios, and so it'll be like the Earth was larger. They will travel as if the Earth is larger because of the refraction. Oh, the Joker laugh is not a good look if you're trying to not be thought of as crashing out.
So it'll be so much larger that it has an infinite radius value in some cases?
If you have total internal reflection, then yeah. Do you know what total internal reflection?
If you have tropospheric ducting, which is when this is used.
Yeah, that's what total internal reflection is.
It's used in tropospheric ducting.
Do you know what total internal reflection is? I'll take that as a no. Look, so I agree.
No, and I'm breaking up again.
I can hear you just fine. Doesn't sound like you're breaking up.
You're breaking up then. I have red bars.
I don't see red bars on your connection, but it's possible. I can't see the red. For some reason, I can't see when you have red bars anymore. But look, I mean, this is a totally.
I think it's fixed.
Okay, so I'm glad that
I answered your question. I said no, by the way.
Oh, that you don't know what total internal reflection is. Total internal reflection is when you have a medium where you have some medium and then some external medium, perhaps, where the index of refraction is sufficiently different between the inside of the medium and the outside of the medium that you can't have refraction, according to Snell's law, to leave the medium, so it just reflects. And you would call it tropospheric ducting. Now, look, we can agree to disagree on this. Why don't we just go look at something that doesn't have any refraction at all, and we can agree on that, and then we can just go look at what shape the Earth is using that kind of method of taking measurement data.
Would you agree that the only variable that they actually use and fluctuate is R? Like,
I don't know why you're ignoring what I just said.
Well, I just want to be on the same page with you for once, right?
I'm trying to be, but you didn't answer what I just said.
The only variable in I'm trying to level with you, bro.
I literally asked you a question and you're just ignoring it completely.
Yeah,
you're not
if
trying
the
to be
only
honest
variable
here.
in the equation, if the only variable in the equation that they actually change is the R value consistently, whether it be in plane surveying, they do the same thing with plane surveying. They use 7/6R as well. Then that's not a constant. You can't claim that the radius value of the Earth is constant. You literally have to fluctuate it to make transmissions work. Mathematically.
Shut up!
Why can't you just answer my question?
Why can't you agree that the only variable in the equation is the R value?
Because I'm not going to agree to anything. I'm not going to answer any of your questions until you can answer mine. Sorry. If you want to engage honestly, you have to be willing to answer questions on occasion.
Is the R value.
That's a cool claim. Now, you want to address my question?
The only variable in the equation is the R value.
Oh my god, it's like a broken record. Somebody poured water on him? Like, what happened? Do you want me to ask it again?
Proceed, but I'm not going to change this top. You want to run away from this. That's what's happening. You want to run away. I'm not letting you. The only variable in the equation is the R value. Why is that?
He's like a broken record. He just keeps saying the same thing over and over again.
Why is it the only variable? Since when does the R value become a variable in an equation? Why is it not a constant?
It's lovely that you want this question answered. To be clear, I have actually answered this question already in the past 15 minutes, but I guess you didn't pick up on it. I asked you a question and you are hilariously running from it. You're like, put on your running shoes, you got onto the track, and you're just sprinting away from it as fast as you can because you know that you'll lose if we talk about anything besides microwaves. You know that you'll look even worse than you're currently looking. Like, I have now spent, like,
I don't think I look all that bad. To be honest, I think I taught you quite a bit.
To be clear, I've now spent 40 minutes with you talking about microwaves, and I still know more about it now than you did coming in, because apparently I can actually understand these equations much better than you can. You thought that when k is 1, that meant that the effective Earth radius was 1 and the true Earth radius was 6378 or whatever. That's not what it means for k to be equal to 1.
No, the division of the two.
Yeah, clearly, and an effective Earth radius does not mean, an effective Earth radius of 6378 does not mean that the electromagnetic wave would follow the curvature of the Earth. That's not what it would mean. In fact, the K value says, it describes it right here for us. In effect, the bending of the beam either up or down makes it appear as though the radius of the Earth is less than or greater than the true radius. That's because of the bending. It's not actually greater than or smaller than the actual radius of the Earth. It's that the bending of the beam makes it look that way. So that's why effective radius is changed in the equations, because that's how it appears to be due to the bending of the beam. Now, we have spent 45 minutes.
But when we model it, we don't bend the beam.
You can do one of two things.
I know you like quote unquote answered that already.
You can do one of two things. You can either make the Earth bigger and not bend the beam, or you can keep the Earth the same size and then bend the beam. They will give you the same answer.
Why don't we do the latter then?
Because the latter is much more complicated numerically.
It's not that much more difficult of a formula.
It really okay. What's the formula for it? Tell me.
Like I said, you would take your derivative of P over your derivative of temperature, probably?
No.
Right? Or derivative of height, maybe. Derivative of height?
Nope.
Pressure over height?
Nope.
Then you tell me.
So there's a general way that you could do this. I understand
you would have to know the frequency.
There's I mean, mildly, but we can even ignore that. There's a general way that we can do this. You would take the covariant derivative, which is in this case in spherical coordinates or in polar coordinates if you want to work in 2 dimensions, of the index of refraction times the path variable. And you would set that equal to you would take the covariant derivative of the path length, the path length vector, like dx d lambda or something like this, times the index of refraction, which is a function of position, and you would set that equal to 0. Now that is a nonlinear partial differential equation. Good luck. Good luck solving that. I mean, it's doable. You could solve it numerically with an annoying like a numerical calculator, but it'd be a pain to do when you could just multiply the true Earth radius by a single number and then solve it as you would normally do it while treating the index of refraction as constant. Like makes it so much easier. And yet you're saying, oh, well, we could just solve a partial differential equation. That's so much easier than just solving an ordinary ODE. I guess an ODE is already ordinary.
Well, of course, but my claim is it's not.
Don't of course me. You don't know what either of those things are.
Original or ordinary differential equation. Yes, I know what an ODE is.
Okay, proud of you.
Let's slow down here, bro. It's like.
Have you ever solved one?
Level math. Yeah, I had to do it when I was doing this. Yeah.
Oh, okay. Which ODE did you solve? Which ODE did you solve? I'm curious.
For atmospheric refraction, just simple ones.
Oh, okay.
You refractive index.
So the atmospheric refractive index. So you solved the. Okay, yeah, sure. But you didn't solve for the trajectory here.
You're gonna get me off. You're gonna get me off guard here. But it's like 0.776 times pressure over temperature, and then you either add. I think you add 0.3. You have to get the water vapor divided by the temperature squared, and then you need a derivative of temperature and over height. Temperature and output of temperature over input of height.
And how did you solve this
Z
differential
would be your
equation?
height.
What method did you use?
It's math, bro.
What
I did
method
not
did you
actually
use?
do it though.
Oh, you didn't.
I filled in the blanks with like arbitrary, like 30 degrees Celsius.
Oh,
100
okay.
feet
So you
height,
didn't
that
solve
kind
the
of-
differential equation. You just plugged in
it's-
values and
it's-
you didn't actually solve it.
Yeah, that's how math works, bro.
No, it's not. Do
You do plug in values and you do just solve things. That's typically
Solving
how
a
math
differential
works.
equation isn't just plugging in values. There's actually like a process to solve a differential equation. There are things like you can use integration. You can use constants of integration to solve second order differential equations, for example. You can integrate both sides if you want to solve a first order differential equation that's separable. Like, there are methods. I was just asking you what method you used, but I don't think that you actually solved the differential equation at all.
Okay. Does that make the Earth a ball?
Well, it makes your critique a little bit, kind of fall on deaf ears, because if you don't know what you're talking about, I'm not really sure why I should care
I feel
about
like I
this.
increased your viewer count by quite a bit. I'm not gonna lie.
I mean, people love to see me cook, but also, to be
Yeah,
fair,
they
you
like to
did
see me
join.
cook too,
You
bro.
did join right as I started, so like people were going to trickle in anyway. But like, look,
Pretty
so
sure I haven't seen you with anywhere near this many views in months.
I
sure
had
you're falling off,
1,200
bud.
views last week when I was live doing the same topic,
Okay.
so that
Fair
was
enough.
300 more. But
Well, so only when you debate flat earthers do you get views. That makes
people
sense.
like the flat Earth content more than the creationism content, because creationists tend to be fewer and far further between, and
I'm a
people don't like
creationist.
philosophy very much. That's a shame. Look, so Sully, you know what would be great, and you know what would make things a lot easier? So hopefully you now grant that solving the differential equations involved for a spatially changing index of refraction for a particle of, a beam of light traveling through the air can be fairly complicated, and you don't like that they use it, that they just make the Earth change its size miraculously to account for that fact. So instead of doing that, why don't we just work with something that doesn't have any refraction at all?
Dude, if you want to change the topic, you can.
Well, we're still going to talk about. We're still talking about beams. We're still talking about figuring out the shape of the Earth by the way that the beams travel. It's the same thing. It's just we're just going to use something that is, a more controlled variable, if that's fair.
I mean, sure, bro. You're desperate to bring up something that you have overwhelming confidence in. I'll give it to you.
I mean, I now have overwhelming confidence in this, not because like I'm an expert microwave technician, but because clearly you have way less knowledge than you thought you came in with, and so like I'm confident that I can come to the conclusions
I would argue that
correctly.
For about less than a month of research into this topic, I'm pretty well planted in my feet. I would argue that I did pretty well for someone who's been studying this for about a
Not
month.
really.
Oh,
anyway,
no, I was
should we
able to
talk
go
about-
toe to toe with you, and this is your profession, and I was able to go toe to toe with you, but I didn't do very well.
No,
Mr.
you didn't
Ego,
do very
that's
well.
cool, man. Okay.
Anyway, so
I had to teach you what the factor of K is. Yeah, that's cool.
well, you didn't tell me it right. This website did.
You thought it was little K.
You thought it was
little K.
You
but
thought
okay.
it was index of refraction. By the way, actually, just as a check, the refractive coefficient that I was using, which is referred to as little k, that I was referring to, is the same quantity, by the way. So this is a paper that I was referring to where they measured the index of refraction.
K versus K.
Here. So here's a table. You have.
What is
this
it you're saying?
So this is so they call it little k, but it's the exact same quantity that you're calling big K. It's the effective Earth curvature radius divided by the true Earth curvature radius. So little k and big K are identical in this setting.
Formulas to derive them.
No, it's the same formula. I mean, like it's effective Earth curvature radius
Can you
divided by
scroll up
true
a
Earth
little bit?
curvature radius. Yeah, sure. Where?
Back down. No, you scrolled past the part. That's interesting. A little bit more. Oh, no,
Here?
no, that's not
This
down,
guy?
Blitz. Oh, now you're lost. Now you don't know where you are.
Here? Where do you want? Do you want
No,
further
there was a
down
graph
below?
there somewhere.
There's
Right
yeah,
above
there's-
it.
Here.
Right above it. The one part that you won't show, isn't that interesting?
I have no idea what you're talking about. Which part? Do you want me to scroll up or down?
Can't even make most of that out, to be honest. It's a little blurry.
I can make it bigger. You should have said something. How's that?
Go up a little bit.
Hold on, let me just make this slightly bigger on the other streams as well. There we go. Okay, up a little bit. Rolling. This one? This graph?
What is this representative of exactly? The value of K?
Yeah, well, not this graph, the ones further down that I showed you just a minute ago. No, these are just measurements.
Measurements
Of the value of K.
Well, there's a lot of ways to derive K.
These are measurements.
Like
Not
like in
mathematical
standard
derivations.
refraction, you don't
These are measurements, not
or
mathematical
standard. I'm
derivations.
sorry, plane surveying you do different.
Yeah, so like
What was
here-
your other topic?
Yeah,
I'll
we
look
can
into
talk
that.
about that. Yeah, so have you ever heard of neutrinos?
Yeah, have you ever observed one?
No, I also have never observed like a bacteria, but you know, I know they exist.
Oh. Well, I've never observed the curvature of the Earth, and I don't think it exists either. So
I didn't say that I don't
Why,
think it
it's weird to
exists
bring up
because I
something that's
didn't.
not observable.
Well, I mean, like we can detect them, we
Weird,
just can't
weird.
see them with our
That's a weird
eyes,
thing.
right? There are a lot of things we can't
You
see with our
detect the
eyes.
probability of them. You detect the probability of them.
Oh, this is going to be really awkward for you. No, you don't detect the probability of them. You detect them directly. They smash into things, and you see light
How?
that is emitted as a result of them smashing into things.
You sure?
Yeah,
How do you know it's a neutrino?
because we can measure the charge of the things that come out. We can measure the trajectory and its
How do you know
influence
what's,
on the
how do you know
on the
what's
magnetic
causing it,
field.
where it's coming from?
How do I know what's caught? Well, you can turn off the source, and when the source turns off, the detector stops detecting things.
Do neutrinos have charge?
No.
And then how does that work?
How does what work?
How do you detect light from something that doesn't have charge? How does it
They
how
smash
does
in-
it transfer energy?
So they smash into things and they interact via the weak nuclear force.
Based on what evidence?
Basically, all of particle physics starting in the 40s up till today. Like, do you
so
want
particle
the
physics is entirely
wait? So just to be clear,
Okay.
you want the evidence that they interact via the weak nuclear force. You want the evidence that neutrinos exist. What do you want the evidence for?
This is your claim. I'm wondering how
Yeah,
it even
okay.
proves that the Earth is a sphere, to be
I'll
honest.
show you. I will show you, and then you're gonna try to nitpick it, and that'll be fine. We'll have fun doing that. Okay. So
You mean I'm going to ask you questions about your claim?
no,
Whoa.
questions are
I
fine.
didn't realize we were in a debate.
Questions are fine. Let me just find the right chart, and let me find some useful diagrams that will be instructive. This is on section 3.3. One sec. I'll show you in a second. I just want to pull them up. 3.3. There it is. Okay, so there is a particle beam. There's a particle collider, in fact, in Fermilab. This is near Chicago. It's just outside of Chicago in Batavia. It's called Fermilab. Surely you've heard of it. It's a pretty big deal.
No.
You haven't heard of
Never heard
Fermilab? Okay, well,
No, it's not that big of a deal. Nope.
I mean, it was a several $billion project, so, you know, I kind of assumed that.
Yeah, so is
That's okay.
child trafficking.
Okay. Anyway, so it's a national laboratory in just outside of Chicago. They have particle colliders. They run a lot of different experiments, but one of the experiments they run is something called the Minos experiment. And what they do is they produce a beam of particles that decay into neutrinos, and then they shoot those neutrinos across a very long distance to a place called Sudan in Minnesota. It's 730 kilometers away, something like this. Yeah, 730 kilometers away. Now, the reason why this is relevant for the shape of the Earth is that if the Earth were flat, you would think that you would just have to, let's say that your beam of neutrinos started out on the surface of the Earth, and your detector was also on the surface of the Earth. You would think that you would just point it straight, right? You would just point it straight along the ground, and then you detect them at the detector. Now, if the Earth was curved, what you would expect is that you would point your beam down into the ground, and then your detector would pick them up coming up from the ground. And indeed, in order to make these detections happen, the particle beam has to aim into the ground at roughly a 3-degree angle, and the particles are detected in Minnesota coming up from the ground at a roughly 3-degree angle. So the particles are going like this. If the Earth was flat, the particles are traveling straight if the Earth is a globe. And the funny thing is, neutrinos, they don't refract at all. They're not charged. They travel in a straight line, right? So, if they travel in a straight line, we need to explain why it is you have to point them down into the ground in order to be picked up coming up from the ground somewhere else 730 kilometers away. And this experiment is like a thing that exists. I have data for you here.
Can you show me a neutrino?
Is that going to be the sum total of your argument? No, like you can't see neutrinos with your eyeballs.
Yeah.
You can't see neutrinos with your eyeballs. They're not photons. You can only see photons with your eyeballs. You're breaking up again, by the way. You there?
Yeah, I know. Photons may or may not exist also.
You can see them directly, so they definitely do exist.
How did you prove that it interacted or does not interact?
Sorry, one more time? You cut out.
You see light. How do you prove that it interacts or does not interact?
That neutrinos interact or don't interact?
Do not interact.
Well, so they do interact. They just don't interact via the electromagnetic force. They don't have charge. Yeah. They interact via the weak nuclear force. It's just rare.
Right. I don't know. This seems pretty trust me, bro. I'm not gonna lie, man. There's not a lot of like, what are you showing me?
I'm showing you data.
How does this prove that the Earth is curving?
This right here. So, and I'm happy to explain this. So this is the data for this particular experiment, and so we can just look at the actual thing. So this is collected data, and then we can look at the neutrino background here. That's the NC. That's that. See those gray bits there? That's what they expect, and that's what they measure when the neutrino beam is turned off at Fermilab, which is, over in Illinois. And then when they turn it on, they get all of the black dots that are fit with the red lines, the red bars. And so clearly there's a correlation between doing something in Fermilab and something being picked up in Minnesota. They turn one off, you get no signal. You turn it on, you get signal again. So there's a correlation there. And regardless of what
correlation, established causation.
I wasn't done. What this is doing is it's establishing that there's a relationship. In this case, yeah, because you have a way to control the correlating factors, right? When you turn one off, the other one does turn off. Sorry?
Any chance you can send me this?
Yeah, it's freely available. I'll just show you the link. You can take a screenshot if you want.
Hold on, let me get a. Can you zoom in? There you go.
I'll show you the link for the other thing too. The other one has a little bit longer of a URL, so I'll have to make it a little bit smaller. But one sec. How about that?
Yeah, zoom out a little bit. Yeah.
Got it?
Okay. Invisible things don't prove the Earth is curving. I will say that.
Lots of things are invisible. Do you think that you can see wind? Can you see the ether?
Yeah, you can see the effects of wind.
You can see the effects of wind. You can't see the wind itself, right? You can see the effects of neutrinos.
You can see, well, technically speaking, like, if you have fog, right, which would still be an effect of wind, like, you would have fog moving, but yeah.
Yeah, but you can't see
ether
wind.
Can be detected.
Ether can be detected.
Got like a 4 kilometers per second.
I'm sorry, can you see it? Or are you just seeing its effects? Because what we're seeing here is we're seeing the effects of neutrinos.
So do you believe in ether now? So do you believe in ether
I don't believe in
ether.
No, I don't believe in ether because we have scientific experiments that rule it out.
But it can be detected.
I don't think it can.
But it can be detected.
I don't think it can. I think that you think it can.
Oh, really? Like what?
But even in
like what?
The entirety of special relativity and all of the evidence in favor of it.
We ruled out ether. How did we rule out ether? How did we rule out
with special relativity?
How did we rule out ether?
With special relativity. All of the experiments that are in favor of special relativity.
Like Lorentz contraction?
All of the experiments that are in favor of special relativity are evidence against the ether. But look, before we can talk about the ether if you want. But my point is,
no. You want to talk about? No, I want to talk about this.
We can talk about it in a second. I just want to put a pin on this. Is that okay?
What disproved?
I just want to put a pin on this really quick.
Ether?
I just want to put a pin on this really quick. So the point is that we have that, like, we agree that there are things that exist that you can't directly see, and instead we measure their effects, like with wind, and in your view, what you think the ether is, right? We measure the effects of these things, and then you can infer that they exist. And so what we're doing here is we're measuring the effect of the neutrinos, and through the last 70 years, basically, we have inferred that these things exist. They have certain properties. We know how they behave pretty well. There are still a few questions, but we know how they behave pretty well. And so now, this particular experiment wasn't about proving the shape of the Earth. It just happens to do so kind of just by accident, because they have to shoot this neutrino beam into the ground at a 3-degree angle. And when they detect it, it comes up and out at a 3-degree angle. And neutrinos aren't the kind of thing that bend. They don't refract at all, and they can pass through solid material of thousands of kilometers thick. So we need to account somehow for this fact that somehow the neutrinos seem to be bending, despite not actually ever bending in any experiments we've ever seen, if the Earth is flat. Alternatively, the Earth can just be a sphere, and they're traveling in a straight line, as we know that they do.
I let you put a pin in that.
Yeah, sure. You want to talk about the evidence for relativity?
What disproves the ether? What does?
It's the evidence.
What
all of the evidence.
ether?
All of the evidence for special relativity is evidence against the ether. Right. The two are incompatible.
I need specifics.
Okay. So are you familiar
I
with?
agree that they're incompatible. I actually do agree.
By the way, for some reason it says you're teacupped, but I can hear you.
Can't call it, bro. TikTok's weird.
Okay. One sec. Let me pull something up. Here's
I promise you, I'm looking at your face. You're looking to.
Okay.
You're right.
Just checking.
Well, you were.
So here is a nice summary. It's a nice web page that has some. Let me just zoom this in a little bit. It'll make it easier to read, and it'll take up less space. So this is maintained by Tom Roberts. The name doesn't have to mean anything to you, but it's just a name. Sorry, I'm just getting the sizing right. And so here's a page that has all the experimental evidence in support of relativity. And we can just go find one that's, and by the way, these are pre-1905 experiments. We can go scroll to particular ones. If you want ones of time dilation, for example, there's a really famous one. Or wait a minute, this is the one I was thinking of, Ives and Stillwell. I was thinking of the one that involves muons, which I think I have somewhere. I made a video about it. Oh, no, I'm sorry, it was this one. It was the measurements of particle lifetimes. So here, they actually made a movie about this, which is really neat, and it exists on YouTube, where they actually like go over what the experiment is and what they showed and how they collected data and things like that. I can pull up the video if you want. It's available. You can watch it on YouTube. Just so people can take a screenshot, I'm going to pull it up.
YouTube videos too. You ever see the principle?
Lifetime experiment. I have no idea what that is.
I'm sure you do, actually. Somebody's probably brought that to your attention.
What's it called?
It actually gets into it gets into relativity pretty good. It gets into like Hubble tension and dark matter and dark energy and the cosmological fine-tuning problems, like the
what's it
called? The Principle, 2014.
I've never heard of it.
You know what the Copernican principle is?
Yeah.
Yeah, it talks about that.
So it's okay. So this is a documentary from 1962. It's 35 minutes long. It's fairly short. And it was basically made as part of an experiment. So you have some scientists that were running this experiment, and I think that they had like an undergrad student, or maybe it was a grad student, that said, hey, you know, it'd be really cool if we also made a movie out of this so that, you know, we can kind of teach people about this strange thing that we're measuring. And so they did. And it's actually like it's just really well done. It's from the 60s, of course, so things are a little bit slow, but I would definitely recommend people check this out. It's a really well done documentary, and it explains how they're actually providing evidence for special relativity. That's what's in question here. In particular, there's a certain kind of muon, or a certain kind of particle. They thought that they were mesons at the time.
Everybody watch The Principle 2014 by...
Okay.
I would recommend the 2014 Principle, the Principle 2014 as well. You see how this is like, we could go tit for tat on YouTube videos?
Well, look, the only reason I gave you this is because people, like, often flat earthers don't like looking at scientific papers. They prefer YouTube videos for whatever reason. So this is a YouTube video where they explain the entire scientific process.
I gave you scientific papers. We talked about scientific papers.
No, we didn't. Are you talking about this? This isn't a scientific paper. This is a PowerPoint by, like, at some, like, engineering
I gave you sources
firm.
from NASA, bro.
You didn't give me any sources from NASA. I'd love to look
I
at
gave
them.
you I gave you a NASA source.
You gave me a quote
I
that
gave
you
you- yeah, I
said was
did.
from NASA,
Originally,
but you
when
didn't
the
give me
conversation
any.
first started,
You
I
didn't
gave
give me
you
any sources when the conversation first started. But anyway, so
I can bring it back up.
if you want more
bring it back
evidence for
up.
relativity, this is the place to go. There are literally hundreds of papers and dozens of types of experiments that demonstrate the validity of special relativity. Like it just goes on for so
Are we gonna
long.
get a chance to talk about the dark matter and dark energy problems that come with relativity?
Those aren't problems for special relativity.
They're not?
No.
Missing mass, missing
It's not.
energy
Those
is
aren't
not
problems
a
for special relativity.
problem?
I have a feeling that you don't know what special relativity is.
How do you remedy them then? How do you remedy
Special
that?
relativity doesn't care about mass at all. Special relativity doesn't include gravity. I guess you don't know this.
Well, general relativity superseded it, so you're not
Yep.
even on board with this.
General relativity
Um,
could be wrong.
and
Special
we're
relativity is
talking
not in
about-
question. And special relativity is the thing that dismantles the ether.
Still, you have. Okay, but you still have missing mass, right?
That's a cool pivot away from special relativity. It's completely unrelated.
Well, you didn't disprove the ether, so you pivoted away as well. Like
I gave you an entire web page. I gave you an entire web page that, and you know, you can prove
You
it for
didn't
yourself.
read a single source.
Do you want me to go pull one up for you? I can pull one up for you if you want.
Yeah, let's read what they say on Michelson Morley. Let's read what they say.
Oh, wait, do you want me to provide you the evidence that I think is evidence for special relativity? Or we could go look at Michelson Morley, but that's just from
We're
before.
talking about disproving the ether, so I would imagine going to a source
Well,
that has to do with ether would be a good place to
be
start.
clear, what we're talking about is providing evidence for special relativity.
Are you scared to show Michelson Morley in front of
No,
1,000
let's go
people?
read
What's
this.
going on?
Let's read this together.
Yeah, let's do that.
Hold on, I'm going to zoom in a little bit just so then it's bigger, so then we can all see what I'm reading. Is this big enough? Can you guys see it?
Relative to the luminiferous ether, yes.
It was intended to measure Earth's velocity relative to the luminiferous ether, which was at the time presumed to carry electromagnetic phenomena. The
Did they
failure of it
assume-
and other experiments to
assume the
actually
ether
observe
was
Earth's
dynamic?
motion. The failure of it and other early experiments.
assume-
Wait, you told me to go read about what it says about the Michelson-Morley experiment. I'm doing that. So please don't interrupt. The
Did
failure
they
of it.
assume a dynamic or a
The failure
stationary
of it and
ether?
other early experiments to actually observe Earth's
they
motion
assume a
through the
dynamic
ether.
or a
I'm going
stationary
to
ether,
read
Blitz?
this. I'm going to read this like you asked me to, okay? This is your request. I wanted to look at muon lifetimes,
okay.
but you
don't want
wanted
to
to
answer
cherry pick.
questions about it, right?
I'm in the middle
You don't
of
wanna
reading it.
answer
We can talk
questions
about it
about it.
afterwards. I'm in the middle of
Do you
reading
want?
it.
Did they assume?
Okay,
this
so-
is a very beginning. This is very beginner
Why
level
don't you just
stuff.
let me read the
Did
thing
they
that you asked
assume
me to read?
stationary? Why
What?
don't you answer my question?
So
Did they assume a stationary ether?
So in the case of Michelson-Morley, they were investigating whether there was an ether
did they
wind.
assume a stationary?
They were investigating whether there was an ether wind.
Did they assume a stationary?
They didn't
They
assume
assumed a
anything. They
stationary
were
ether.
looking for an ether wind, and they were trying to see if
And they did get a
measurement.
friendship.
They were trying to see if there was any sort of detectable ether wind, and the answer is apparently no. The failure of it and
They got
other
a
early
friendship.
experiments. The failure of it and other early experiments to actually observe Earth's motion
They
through
got
the
a
ether.
friendship.
Okay, so I'm going to take up my headphones and I'm going to turn you down so that I can finish reading this. Okay. So the failure of it and other early experiments.
I'll see
to
my
actually
way out,
observe
bro.
Earth's motion
I'll
through
see
the
my
ether
way
became
out. This is
significant
taking
in
up
promoting
too much of
acceptance
my time.
Einstein's theory of special relativity, as it was appreciated from early on that Einstein's approach via symmetry was more elegant and parsimonious of assumptions than were other approaches, those of Maxwell, Hertz, Stokes, Fresnel, Lorentz, Ritz, and Abraham. The following table comes from R. Shanklin et al., and here's the citation, which includes references to each experiment, resolution, and limit on the ether from the original sources. The expected fringe shift is what would be expected for a rigid ether at rest with respect to Sun and Earth's orbital speed, 30 kilometers per second. So the Michelson-Morley, so they expected a 0.04 fringe shift, and they measured a 0.02. Apparently, they didn't provide an experimental resolution. That was Michelson. The Michelson-Morley expected a 0.04 fringe shift and measured less than 0.01. with an upper limit on the speed of the ether of 8 kilometers per second. And then we have a whole bunch of other experiments, Morley, Miller, we have Tomaszek, we have Miller again. This was a reanalysis done here. We have Kennedy, Illingworth, Picard and Stahl, Michelson et al., and Juice. So apparently before 1950, it was common to not perform a detailed error analysis and to not report error bars or resolutions. Now that I'm done reading that, do you want to say something? Oh, did I turn myself down? I may have turned myself down. Rest in peace. Oh, he ran. I also turned myself down. Wow, that's so cringe. I can't believe I turned myself down. Apparently, I must have cooked him really hard. Feels bad that I turned myself down, though. Aren't I like obviously professional? No, I know, but YouTube didn't hear me. Well, that was kind of embarrassing for him, huh? Let's see if he joins back into live. I mean, like, I'm happy to cook. It's you know, I may not cook in the kitchen, but I definitely cook on the live stream. But he definitely ran away pretty quick when I started reading. I mean, look, like, I get that he may think it's rude that, like, I didn't let him continue talking while I was trying to read the thing that he asks me to read, but you have to let me read the thing, right? Anyway, there are, just so you guys know, just so then we can make this at least valuable education-wise, the relevant thing that I actually wanted to bring up, which is fascinating, is this particular one, which was done by, who was it done by? Frisch and Smith, and I think that there's a paper, yeah, here it is. I think it's this one. So here's the paper. So this is the paper that this documentary is based on, or the documentary filmed the recording of the data for the paper. So here's the paper. It says measurement of the relativistic time dilation using mu mesons. We now call those muons. An experiment has been performed to demonstrate the relativistic time dilation as a large effect using only comparatively simple equipment. Mu meson incident on top of Mount Washington, New Hampshire, were selected to have speeds in the range of 0.9995 C and 99954 C. 9954 C. The number of these which survived to reach sea level was measured in Cambridge, Massachusetts. The number expected without time dilation was calculated from the distribution of decay times of these mu mesons, i.e. the mean lifetime is measured in both this experiment and others, and from the known distance of descent. The observed time dilation factor is 8.8 plus or minus 0.8 to be compared with the effective time dilation factor calculated for mesons of these speeds in our detection geometry of 8.4 plus or minus 2. Which is to say, and I can just summarize what's going on here because it's a fascinating experiment and it's really well done. So, which is to say, you have these things called muons. They come down from the sky. They rain down, and they only last for a certain amount of time. If you make them on Earth, which you can in particle accelerators, if you make them on Earth and they're really slow, they decay in about 2.2 microseconds. Now, if they started out very high up and they rain down, then you'll detect more higher up than you will. Oh, please turn your volume down. Oh, turn your volume up? Oh, okay. This is really delayed. The volume should be fine though. So, hopefully anyway. So the point is that you'll detect more on top of a mountain than you will at sea level because some of them will have decayed as they go down. And so you can predict how much more you will measure at the top of a mountain compared to at sea level based on that decay rate. Right? And so if you assume that there's no time dilation, you will get some ratio. I think that you'll detect like what, 1,000, like a 1,000 times more at elevation than you would without it. I'd have to go rewatch the documentary again. But if you do assume time dilation is a real thing, then you expect like a factor of 8 difference. Like you only expect to lose a few. And lo and behold, what you find is that actually the muons, they decay more slowly when they're raining down from the sky, when they're going at 99.5% the speed of light. So this experiment actually demonstrates that the internal clock of a muon is much slower when it's traveling very quickly. And that's time dilation, right? That's evidence of special relativity. Anyway, let's read some super chats and we'll bring on our next guest. From Jack Fetter with the $5, Sully got destroyed the other night by MC Toon with the same derp. He's a Timu physicist. He just makes up science to suit after a ChatGPT session. That checks out. Yeah, it seems like he didn't understand what solving a differential equation is. It seems like he didn't understand what the coefficient of refraction is. He didn't understand what refraction is really. So that kind of checks out. From Ellie Els with the two euros. Oh no, the FLERF Wi-Fi strikes again. Yeah, it's like he unplugged his Ethernet cable. From Jack Fetter with the $5, Sully, you were fully shut down the other night with the same argument. Physics didn't change to suit your understanding since then. Sorry, bro. Fair. Maybe I'll go watch that with MC Toon. MC Toon's a good guy. From Jack Fetter with the $2. If I were Sully, I would have stopped at curved. Yeah, I don't know why he brought up, like, I mean, it's the first law of FLERF that the FLERF, all the FLERF sources actually say the opposite. From Ellie L's with the €2, they never read their own sources. No, it's the first law of FLERF. From Jack Fetter again with the $5, Sully just went full Witsit. You're getting totally cooked, bro. Your daddy FLERF would be so proud of you. True. From Sherp Brother with the $10, Sully is one of the dumbest people I've heard in a long time. What an absolute mouth breather. Dr. Blitz is an excellent communicator, and this idiot refuses to step away from his FLERF dogma. Yeah, because if he does, then he'll lose his friends, and he's already probably lost his family and his other friends from it. From Tim Bimbadil with the $2, imagine calling mathematics mumbo jumbo. I mean, look, it's just a thing that they gotta do, right? From Ellie L's with the €2, please admit you got cooked. Yeah, he was really begging for it there, wasn't he? He was really begging for it. From Jack Fetter again with the $2, Sully goes into his Riddler laugh when he reboots. Maybe the Riddler laugh will be the intro for the YouTube video. From Shirt Brother with the $5, Sully, you sucked. You didn't go toe-to-toe with anything, but as you dizzied yourself huffing your own farts. What a moron. Yeah, I mean, going toe-to-toe doesn't just mean showing up. You actually have to, like, make convincing arguments and, you know, win the rhetorical game or something, right? From Gravity Hits Hard with the $2 Australian. Quick, Sully, explain Minos away. Well, yeah, he's just going to say, well, how do you prove that neutrinos exist? Like, I mean, obviously that's their move because they don't understand these things. From Young Kaleido with the $5, can you please just admit you got cooked? My FLERF friends are watching. Yeah. From Jack Fetter again with the $2. Okay, Sully, your time is up. Come play again. Sigh. Well, I mean, he ran. I didn't know what why he ran. I was just doing what he asked. From Shirt Brother with the $2, Sully is dumb as hell. Being dumb should hurt. Probably it should, yeah. From Mr. Pecho with the $20, turning yourself down is just the flat earth debate version of Goku training in hypergravity. Yeah, that was cringe. I moved the wrong bar. My bad, y'all. And from Half Fiction with the 2 Canuckbucks, lol, Ethernet cable. That's funny. I didn't even do that on purpose. Somebody in the TikTok comments, by the way, said you can make a documentary about anything you want to. Yeah, you can, but it's the content of the documentary that's relevant. In this case, they go over the data analysis, they go over the techniques, they make it all seem very, very intuitive. And so, like, you don't have to read you don't have to watch the documentary if you want. You can just go look at the paper. The paper is freely available. You know, but flat earthers don't like to read. They would rather just look at a YouTube video. Hence why I brought up that there's a documentary that you can watch. Because then you don't have to read. It's not even a long paper, it's only 14 pages. And it's also an old paper, so like it's written in a way that's very understandable, but you know. I guess what is that reading is woke? What happened Sully? I just got cooked. He ran away. He ran away in the middle of me doing what he asked me to do, which is kind of awkward. Okay, let's bring up our... Wow, that's quite a name. I can't believe I turned myself down. That's so rough. Man, I'm so bad at this. And I couldn't even see my mods telling me that I turned myself down because I had something up covering my Discord chat. Anyway, let's bring up just random up. Just random up.
Hello.
How's it going?
Good. So
What shape do you think the Earth is, bud?
I think it's flat
Okay. Why do you think it's flat?
because I don't really believe in gravity, and somehow people on the bottom are not falling.
Why would they fall if there is no bottom in space?
I mean, I don't know.
Look, so down is towards the middle of the Earth. So if they're on the bottom, they're still being pulled up towards the middle. Right? So there's not really an issue there, I don't think.
Well, I don't know.
So now that I've cleared up why They wouldn't fall off the bottom. Do you believe in gravity now?
Yeah, I'm just trolling, Dr. Blitz. I'm a big fan of you.
I don't like that. Please never do that again. It's not funny. I don't enjoy it. Like, if you're gonna troll, you at least have to be good at it, right? You have to be good at it, and it has to be funny. It can't just be talking in monotone, slowly and tired. Like, it's not funny. From the guy who does, how's it going?
It's going all right. What about yourself?
I'm doing okay. So the guy who does, what shape do you think the Earth is?
Concave.
Concave. Okay. Really? Why do you think so?
What do I think so?
Yeah.
Well, so you use general relativity, right?
You mean like in my professional work? Sure.
Well, like just the general scientific body, right?
Sure.
So if we take a look at the equations, you can actually make concave Earth work because is this a troll? Yeah.
Mods, block him for, I don't know, a week? Trolling has consequences. Nicholas.
Hello, my friend. I'm not a troll, and I'll be honest with you, I'm absolutely not a flat earther. So,
why are you here?
Because I just want to state that I think being a flat earther is intellectual psychopathy.
I agree. Thanks for being here, Nicholas. Let's talk to B-Rad. B-Rad, how's it going?
Going pretty good. Could you explain that word to me, that word he just used?
It just means that, like, it's a descriptor for psychopaths. Now, B-Rad, what shape do you think the Earth is?
Well, round.
Okay.
But I was...
Next person who joins up who thinks that the Earth is round is going to get blocked permanently, by the way. Just so you know. So if you're in the guest box, you think the Earth is round, and you get caught, you're going to get blocked forever. Okay?
Hello.
Nanook, how's it going?
How's it going? I just had one question. Does this ruin your faith in humanity doing this?
No. Nanook?
And the Earth is flat.
Nanook was not a flat earther, I don't think. Mizix, how's it going?
What's up, man?
Mizix, what shape do you think the Earth is?
I think it's very round.
All right. Mods, you guys know what to do. Instant block. Bye forever. Them's the consequences. It costs me viewers. Don't care. I don't want you here. If you come up to troll, you get blocked. If you come up just to, complain about something, you get blocked. If you think the Earth is a sphere, you get blocked. So don't come up, okay? Krzak, how's it going?
Nigger.
You also get blocked if you do that, by the way. Let's bring up Player. Player, how's it going?
Yo, what's good, man?
Player, what shape do you think the Earth is?
I know it's flat, bro.
Why do you think so?
Look, yeah, today I was at the beach. I was basically at water level, maybe 10 centimeters, 20 above sea level.
You must be real short.
Yeah, I'm real. I was directly watching through the beach level, about 30 kilometers longer, right? I could see the whole, I don't know how to say it. Basically, I could see the floor from 30 kilometers away at 10 centimeters above sea level.
The floor of
that's
what?
impossible, fuck love. And now go and see the refraction thing, come on.
Wait, so you can see the floor of what?
Of the city.
What city?
It's called La Pobla de Farnals here in Valencia.
Okay, so you can see. Why should I believe you?
Right. Don't believe me, but if what I saw it's real, because it is, what would you say?
Well, I would be very, very perplexed because, you know, I have a ton of evidence that the Earth is a globe, and you're trying to say that, well, there's some observation that we have that is supposedly true that would contradict that. So, I mean, like, look, if this was like a demonstrable, repeatable thing, then absolutely, I would be like, yeah, that's a good point. We have some investigating to do. But I have a feeling that you're just now, player. What if I said that I was at the beach and I could only see the top half of the tallest skyscrapers at the city across from me? What would you say?
Right. Yeah. It's the atmosphere effect for sure.
Ah, okay. So when I present you with evidence, you're just like, well, there's some atmospheric effect. But when you present me with evidence, I'm like, well, let's look. We should look into it. How do you know it's an atmospheric effect if you haven't looked into it?
Right. Yeah, because you can see the atmosphere. But anyways,
you can see the atmosphere.
You
Cool.
would say it's refraction, right?
I mean, it would. Maybe it's because the Earth is actually flat. If that data is real and there's no refractive effect, but I would have to look in. I would actually have to look into the claim here, and all you're telling me is just like, just believe me. What would you say if it was true? So, like, you know, if it was true and there wasn't a refraction, then you'd be right. I just don't think it's true.
I actually lied. It was like 27 kilometers. It was not 30.
So yeah. So it's 27 kilometers, and sorry, what could you see? You could see the floor.
Right. I was inside. I was inside of the water, right? And I was like, my head was outside, and I could see all through till the city, basically.
So why is it that like I can't see ships? Why is it that like when I'm looking at a ship on the horizon, it eventually just disappears, regardless of how much I zoom in?
Right, because there's the atmosphere effects.
Why couldn't I just say the atmospheric effect is causing what you saw?
Because you cannot see through infinite space because the air is distorting the image.
What?
That's why you cannot see clearly at maybe 120 kilometers.
What? What are you saying?
The atmosphere air, you know?
Okay, yeah, what about it? Why couldn't I say that it's an atmospheric effect is causing what you were seeing?
No, I mean, you can say it and you can still believe in that the theory of nothing, that you came from nothing and go into nothing. You're free to do it. Do you believe in God, bro?
I don't.
Yeah, no shit, you don't, man.
Well, most flat earthers believe in God.
All flat earthers.
Sorry, let me rephrase. Most globe earthers believe in God.
Yeah, because humans are meant to believe in something, but anyways.
So it's not really related. Whether or not you believe in God doesn't really affect your probability of believing that the Earth is a globe. Not really. I know some young Earth creationists. I know some young Earth creationists who are globe earthers, and they actually argue with flat earthers, even though they think the Earth is only 6,000 years old and that the Bible is literally true. So like it's not really related. What is the case is that overwhelmingly people who are flat earthers are also Christians, occasionally Muslims, because they think that their book says that the Earth is flat. But unfortunately, the evidence says something to the contrary. So what do you make of sunsets?
Right, the sun just disappeared beyond the horizon.
How does that work?
He moves.
No, I mean like how far away does the sun have to go before you can't see it anymore?
So far.
How far?
I don't know exactly, but so far as we can see in the sunset.
Because like if I'm standing at sea level, I'm a pretty tall guy. So you know the horizon is 4.5 miles away from me, right?
Right. Which is not bad. Okay.
So that's 4.5 miles, right? But the sun at sunset, the sun is, you know, I'm in the southwest of the United States, and so when it's sunset for me, it's going to be roughly noon, maybe a little bit, maybe early in the afternoon in Hawaii, for example. Now, Hawaii is, I don't know, 2,000 miles away? How far is Hawaii? 2,900 miles, just about 3,000 miles away. So how is it that I can still see the sun when it's at least 3,000 miles away if the horizon is only 4.5 miles away?
You can see it depending on where you're on where you are. The Earth is so big; it's really big. So if you said 3,000 kilo. No, how much far you said?
Around 3,000 miles. So that's around 4,700 kilometers.
Right, 3,000 miles. It's so much kilometers to move and have a different point of view of the sunset. But yeah, if you are in a road, you're not gonna be able to see it till the end of the road. But
no, I'm just confused, right? If it's going behind the horizon, and the horizon is only 4.5 miles away from me, you know, that'd be what, like 7 kilometers or something? Why is it that I can see something that's 4,700 kilometers away if the horizon's only 7 kilometers away?
There's no correlation between what is above and it's moving through the horizon and where the actual horizon is, which is not at 7 kilometers. If you're sitting at the beach and pointing forward, you're not only gonna see 7 kilometers, you can see way more. And there's a lot of observations that disproves that claim.
Oh, so you think that the horizon is further away than 7 kilometers?
It is, yeah.
Oh, okay. And this is from like 8 feet above sea level, by the way.
Can you talk in meters?
2.5 meters.
2.5. Yeah, right. So there's this. For example, my own observation, which I was 10 centimeters above sea level, I could see 30 kilometers away. How does this work?
Well, I kind of think that you didn't.
Okay, don't believe me, but like, just act like I did, because I know I did.
All of the data that I've seen to the contrary is that if you're 10 centimeters above the sea, then unless you have very, very special atmospheric effects, you're only going to see maybe a kilometer or 2.
I can go back to the beach and make a video for you. I was gonna make it, but
sure. I mean, that'd be reasonable.
No,
but look, we can talk about photos if you want.
I will make a video and hop on here, and I mean,
we can just talk about photo. Like, we could just go look at photos if you want.
No, I'm just proving you what you said I didn't, which I did.
Okay, well, next time take a picture instead of just making a claim, I guess. So
I'm telling you, if you don't want to believe me, don't. But if you're gonna go with the hyper mega super hyper refraction, saving your globe as always.
Sorry, one more time. Super what refraction?
Super mega hyper super big refraction.
You don't need particularly large refraction in order to see anything substantial. Sorry, I just gotta take care of something really quick. Okay. Lou, you have been dubbed Sir Lou. Actually, Lady Lou. Sir Lou sounds better, but I don't want to misgender you, so you've been knighted. Anyway, so look, the point is that, like, you can even ask flat earthers and they'll be like, well, yes, the horizon is 3 miles away because of the, you know, the angular resolution of the human eye, blah, 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 blah. Like, even flat earthers say this, so I don't know why you're rejecting it. The point is that on a normal day, Dame Lou, yeah, there you go. On a normal day, you can only see a few miles. And, you know, ships will disappear once they go beyond that distance. Boats will disappear once they go beyond that distance. You will start to see only the bottom, like the top half of buildings beyond that distance, and so on. So I'm just asking, why is your observation so different from literally every other observation I've ever seen?
I'm not saying it's different, but I'm saying depending on how the atmosphere fraction and all that, how is that working? You see longer or you see shorter? But
the
anyways,
thing
the ships and the buildings
average.
Disappear from bottom up is not exclusive to a globe.
I'm not saying it is. I mean, it is exclusive to a globe, but the point is that it's at least exclusive to a horizon existing.
Yeah, to a horizon and an atmosphere.
And your horizon is not 30 miles away when you're, or 30 kilometers away when you're 10 centimeters up. But I mean, like, we can just go.
So it wasn't even 10, and maybe it was 5.
How do you know that you were seeing the bottom of the buildings?
How did I know what?
How do you know that you were seeing the ground?
I know the buildings. I pass through them when I go to my other house. I pass through them, and I know how tall they are. I could see the beach. I could see all.
Okay.
I know what I'm watching.
Your eyes are so good that your eyes are so good that you can see the beach from 30 kilometers away.
Not the beach, but you know the.
I thought you hold on.
I don't know the word. I don't know the word in English.
Then
but
hold on.
All the bottom of the city.
I just gotta check. Did you or did you not say literally every other observation I've ever seen? Hold on. Let's just.
Did I know what?
How do you know that you're seeing the ground?
I know the buildings. I pass through them when I go to my other house. I pass through them. And right. My English is not my main language. I'm trying to, but
okay. So then you agree that you can't see the beach.
I shouldn't even be able to see the buildings. That's the problem.
Why not?
Because they should be below the curvature.
So to be clear, we're now agreeing that you can't see the beach.
I could see the bottom of not directly the people walking in the beach, but
Okay, so you couldn't
I
even see
don't
the
know the
people
word
on
in
the
English,
beach.
the linear horizontal line in the beach, you know?
I don't know what horizontal line on the beach.
Yeah, I don't know the word in English, but alright, I pull my camera to show you. Let's say, you know, here's this is the city, right? And
I don't know
this
what I'm
part
looking
right
at.
here. This right here. Let's say this is the city,
Mhm.
right? And there's buildings and shit. One taller, one smaller, but at the bottom, this thing right here. I don't know how is it called.
I don't.
Horizon, maybe. I don't.
What?
I don't know.
There isn't like a bottom of the city. Do you mean the shore?
No, there's a lineal at the bottom, all the way through the buildings.
Is it a wall?
Not a wall. The beach would be basically. I couldn't directly see the people walking in the beach, but I saw it in the far.
Okay, so if you couldn't see the people on the beach, how do
street,
you know?
yeah, the street, the horizon, the
So
ground. Yeah,
so you can see the street. You could see the street,
I could see the ground at the same eye level as I was.
and so you're telling me that you can see the ground from 30 kilometers away with just your eyes. 27 kilometers away with just your eyes. No zoom or anything.
No zoom.
Okay, now
My eyes.
we can just work this out. How big do you think the thing you were seeing was?
Do you mean the buildings?
No, the ground that you were seeing.
How big it was?
Yeah, like how tall is this? How tall is this like embankment of ground that you're seeing?
Maybe it's 400 meters long.
I'm not asking how long it is. I'm asking how tall it is, like this.
Oh, I don't know. It was like pretty.
Got to be pretty short because you're looking at it from the side, right? You're not looking at it from above.
All right, but I know the buildings, and they
Well,
were
hold
all.
on. We're not talking about the buildings. We're talking
height.
about the shore or the beach, the something that you saw, right?
Yeah,
Okay.
exactly.
So how tall was that? How tall was the lowest thing that you saw? What is it?
You want me to say how many meters was I seeing exactly at the bottom?
No. So like, look, if you're seeing the beach, how tall is
Right.
it vertically from the sea to like where the beach stops being beach and just starts being the ground or like the sidewalk or something?
Maybe
10 meters?
from my point of view.
No, I mean you've been there. So how much? You've been there. So like, how tall is
No,
it actually?
I've passed through the carretera. How is it carretera? To the road.
Maybe
It's
you
a
can just
city.
actually tell me where you were and what direction you were looking, and we can just do this like
Sure.
live. So where were you, if you don't mind me?
For sure. Wait, put my camera on.
Well, you can just tell me where it was, and I can go find it.
Sure, but I can prove. I made a screenshot from where I was sitting. Look, there it is. Here I was.
I can't see what you're showing me. Can you just tell me where you were? Like what city were you in?
Yeah, Valencia, Spain.
Okay, you were in Valencia. Got it. And which direction were you looking?
I was Playa. Wait. It's big here. Let me go on the PC and check on Google Maps exactly. But I was on El Cabañal,
How do you spell it?
right next to Cabanyal. Cabañal. And I was
Okay.
inside of the water, and I was looking through. I saw La Pobla de Farnals to the left, and then to the right I saw Sagunto, the bottom also.
Okay, so I'm just gonna pull something up for you, and then you can direct me,
Sure.
okay? Because it's hard for me to see what you're looking at.
I'm not looking at nothing. I'm
Okay.
remembering now.
So you were
I
right about.
understand.
So I'm on Google Earth here. So you were right about
Sure.
here, somewhere in
No,
this
more
area.
to the you see. Wait, go down. No, more down. More down. I was closer. No, like there where you were. Go again.
Yep, here.
But a little bit more down. More down. A little bit. Right there. Yeah. So yeah, right there.
Okay, I'm gonna put a pin right here. Okay, like right there.
Right.
Now, what were you looking at?
All right. I was looking. Go up. No, I mean down. No, go down. Go down. Scroll into it so I can tell you. Go up. Up. Go up. Keep going. Keep going. Yeah, this is La Pobla.
Okay, so what,
so I
were you,
was
what were you
seeing
looking
this.
at? What were you seeing?
All of it, all of the buildings, like through the left to the right.
So, I mean, these don't look like they're particularly tall buildings.
They are.
So what was the like? You said that you didn't see the beach, but you saw.
Yeah, but I could see.
Are you talking about the pier? Is this the one?
Yeah,
the
all of
pier?
that. All of the.
Okay, I'll just plop one down there, and then we can measure the distance.
No,
so,
but I could see more. I could see more. Go more.
Well,
go up now. Go to Sagunto.
Okay, you want to make this worse? Okay.
Worse?
Yeah.
Okay. All right, go up.
Sorry, 1 second. Just gotta click at it.
It's exactly right there.
Here?
Graubel, no, to the right.
Here.
Exactly. Yeah, but a little more inside of it. Yeah, you see these 4 things? You see these 4 big things in the right? I was seeing all like
my computer's
2
freezing.
or 3 from my point of view, but because the other were hid by the others, not because of the curvature of the earth.
Sorry,
Right,
1
so
sec.
I was
My computer's freezing. The browser is.
No worries, no worries.
Let me just close out of this. And let me reopen. It just really didn't like that.
Right.
Okay. We're back. Okay, so where is it? It was like here?
No, to the right. In
here. Oh, these things.
These things.
Okay. So let's just take those 2 locations. Now let's measure the distance just to get a correct distance. So we have from here to here. It's about 20 kilometers. A little bit less.
ChatGPT told me 27, but okay, I will say he was wrong.
It's 20.45 kilometers. Now, oh, that's so cool that it gives us an elevation profile. That's the coolest thing. I had no idea. That's super neat. Okay, so that's so cool. Okay, let's see if we can plop down a person here so then we can look around. Let's just plop down a person right there and then we can see. Okay, so this is where we're looking. You were looking at these things, right?
Exactly.
Okay, now, how do you know that you were looking at the bottom of them?
Because they look like that, right? Like that, like you're seeing.
Okay, now let's go to. I'm gonna take us all the way back to where we started from, and I'm gonna plop a person down over there.
Sure.
From like, actually, we'll just be like, there's a beach location right there.
Huge.
Right.
Yeah.
Now, any of this look familiar?
You can see it. You can see it from here.
What am I seeing? Are you talking about these?
Yeah, these are the things. Yeah.
Okay, so we're talking about these little things. Now,
right.
I just want to verify that this is indeed the. So this is we were pointing. I would like to show heading. I want to verify that those are actually the things. So we are currently pointed. Tell me the direction, please.
I was looking to the left.
Okay, so this is because I would like to see like the line drawn, so then I can see that it goes to the right place. But I guess that it might not want to do that. That's fine. But so plausibly, those are the things. It's plausible. It'd be a little bit far-fetched, but I don't know what else you'd be seeing. Okay, now let's go figure out what are those things. Do you know what they're called?
No.
Okay, I don't know what they're called either. We can probably figure it out though. Do you know what that whole thing is?
No, I don't know. My friend told me, but I remember it's like a father built something. I don't know.
Okay, so what's this place called? This place is called Grauvel Towers. And we want no, they're not towers. What's this called? This thing. It's the industrial port. Industrial port. What are they called? Tanks. Sorry. So I'm just trying to see if we can figure out how, because those are like oil tanks or something, right? I'm just trying to figure out if we can figure out how tall they are. But they are really, really big, right? In fact, we can probably get an estimate as to how big they are based off of how tall they are, or based off of how wide they are. So they are almost 100 meters across. They're 83 meters across. And so if we just go, and so that would be the same distance this way, right? 83 meters. And And so if we go to, we're gonna do this. Don't worry. If we go here,
Sure.
and we look, so they are 83 meters this way. So they're gonna be like 50 meters this way, right? At least.
Right.
Not they're not quite as tall as they are wide, but let's say it's 50 meters. Now, from a distance of 20 kilometers, what we're gonna do is we're gonna go to the advanced Earth curve calculator. Sorry, I have to clear my throat. What we're gonna do is we're gonna put in a target that is 20,000 kilometers or 20,000 meters away. The target size is 50 meters tall, and we're just gonna lower you to be 10 centimeters off the ground. Well, then you would expect to see the top half of them.
Right.
So it's actually not surprising, and it's entirely consistent with our observation over here, wherever it is. It's entirely consistent with our observation here that you can see a little bit of them. You certainly can't see all of them, but you can see a little bit of them, right?
Yeah, but I saw, but it was a very clean day. It was full.
Well, yeah. I mean, like obviously on this day it's not as clear, but the point is that like that's expected on the globe that you should be able to see them at least a little bit.
Right. Here's from the beach. This is 1 meter away. I was inside of the beach.
I know, but I understand that. But even on the globe, we would expect you to be able to see the top half of those storage tanks, even if you're only 10 meters above the water.
10 centimeters, you mean?
Sorry, yeah, 10 centimeters. Even if you're only 10 centimeters above the water, you should be able to see those storage tanks. The top half of them.
In the top half, but I was seeing them entirely.
How do you know what percentage you were seeing of them?
Because they were looking really, really...
There's no way they were looking big because they're very, very small from that far away. In fact, you can hardly see them at all.
I know what I was seeing,
and like there's no way that like your eyes are like better than like a zoom camera, right? I'm just trying to find so these pictures are taken at different times. I'm just trying to find a day where it's clear. So like I don't even see them anymore. Maybe there's a more clear picture from the road.
There's a curvature drop of like 30 meters or something.
Yeah, so there you can see them. There's no way you can tell what percentage you're seeing of them just by looking at them like this, because they're so tiny.
Well, my eyes they're pretty good, you know.
Your eyes are better than like a
observation.
top-tier camera.
Better longer distance observation.
Right,
like
but you're
Chicago.
not seeing longer distance with your eyes from 10 centimeters above the water. That's the reality.
What? Can you repeat?
And now, okay, don't bring up Chicago. You've never been there and made those observations yourself.
Right, but it's real anyways.
Okay, well, I can tell you about the real observations of being able to see cruise ships disappear, not as a result of atmospheric effects, but just because they get lower, even on clear days.
Right, but when they're about to fully disappear, the top disappears also. It's just the reflection of the
No, they disappear bottom up slowly.
Right, but when you're about to get it fully, I saw different videos from the ships disappear, and when they're about to fully disappear, it's like the top unifies with the atmosphere effect on the horizon, and it's like disappear. There's a big line in the middle. It's not only.
I don't know what you're referring to.
That's not only
so what you're I think what you're referring to is a mirage.
No, not a mirage. Yeah, but just at the end, not when it's disappearing.
So
you can go watch a video for.
I mean, we can pull one up, but like, look. Sure. So do we agree that there are atmospheric phenomena, that like depending on how clear the day is, you can see more or less, and like there's a lot of variables here.
Sure.
So why don't we just why are we using something that has so many variables when we can use something that has so few variables? We can just, for example,
sorry.
Like we can just, I mean, I could bring up neutrinos, but neutrinos are probably, well, maybe they're too much. But like we can just think about the sun, right? Sure. So the sun, regardless of the atmospheric effects, right? This is always true. We always see the sun disappear below the horizon, right? Every unless it's like really cloudy, right?
Ships.
Well, right, but this is regardless of atmospheric effects, right? This happens every single day, unless it's really cloudy and then you can't see the sun at all.
Right.
So my question is, Why is it that the sun gets lower in the sky, but it doesn't get smaller like the ships do?
It does sometimes.
Does it? Are you sure?
Yeah, I've seen bits. No, maybe you gotta be not not at sea level. You gotta be on maybe on a mountain or something. But yeah, you can see how it
Can I show you
makes it
something?
slower. For sure.
Oh, this is not the one that I wanted. This is what I wanted. That's just a sunset video. Sunset videos are nice, but like you can see that it's like it's getting smaller this way, but it's not getting smaller in the horizontal direction. It's just getting lower. But what I wanted to show you was this video. So here we have a camera pointed at the sun with a solar filter on it, so it filters out all of the glare, and they're recording the size of the sun over the course of an entire day, from sunrise to sunset, 12 hours. And they're just going to calculate the diameter of the sun over the course of that 12-hour period. By the way, this is by Icy Spin, so credit where credit's due. I'm just going to speed this up a little bit because it's kind of annoying to watch. So right now it is it's like 8:30 in the morning. I'm just going to skip ahead because it's very uninteresting, right? The size is completely, so just to be clear, between 8:30 in the morning. So here, this is 8:30 in the morning. Come on. Okay, this is here is 8:30 in the morning. The size is 684 pixels. And then if we go to noon, when the sun should be closest, the sun is 684 pixels. So over the course of 3.5 hours of the sun traveling towards you, right? That's what you think is happening. The sun should be traveling towards you for 3.5 hours, and the size doesn't change at all.
Apparently it does.
We're looking at it right now. At 8:30 in the morning, it's 684 pixels, right? And then over the course of the next 3.5 hours, its size doesn't change at all.
It does not prove that the floor is curving.
No, but it does prove that the sun isn't getting further away.
Does not prove.
It does prove that the sun isn't getting further away. Because if the sun was getting further away, if it was getting closer and then further away over the course of a day.
I'm back. I got disconnected.
You're fine.
Disconnected. Can you repeat? Sorry, I was.
So if it were true that the sun were overhead and it was far away and then it got closer and then it got further away again, then the sun should be changing size over the course of a day. But it doesn't.
Maybe if there was no atmospheric effects, it would. Maybe if you're watching a ship disappear over the horizon.
Do you see any atmospheric effects here? Do you see any atmospheric effects here?
He's literally filming. It's filming through the atmosphere.
Well, yeah. So why would the atmosphere make the sun appear bigger in the morning and then not appear like? Why would it make it so that it appears exactly the same size across the entire day? It's only once we start getting to late evening that we start to see it shrink this way, not horizontally. It shrinks this way.
So
is
the sun moving?
Apparently not. Apparently not. See how it's getting smaller this way? That's the atmospheric effects. See that? See how it's like kind of squished this way, but not squished horizontally? See how it's kind of squished?
So?
That's the atmospheric effect. The atmospheric effect won't change the horizontal size. So why is it that the horizontal size is effectively unchanged throughout the entire day if it's getting further away and closer? Or if it's getting closer than further away?
This doesn't prove the floor curving.
Yeah,
it's just proving the sun moving
reciting
on top of
that.
us.
Keep saying that.
Yeah,
address what I'm saying.
The floor
address
is,
what I'm saying.
Yeah, but that doesn't prove a globe.
Great. Address what I'm saying.
What do you mean address? What's address?
Why is it that the sun isn't changing size in the horizontal direction throughout the course of a day if the sun is in fact traveling overhead, zooming along as the day progresses? At noon it should be closest to us. In the morning and at night it should be furthest away from us, and yet it's the same horizontal size the entire time. Why? Why doesn't it change size? When things get far away, they're supposed to get smaller, right?
It moves on top of us.
Why doesn't it get smaller as it gets further away?
Should not be getting smaller. The ship does not get smaller horizontally.
Things don't get smaller as they get further away?
apparently with the eye, yes, as the sun. If you go on top of the mountain like I do,
I'm gonna do a demo for you. So look, see how my fist is as wide as my head here. So it's as wide as my head.
Sure. Right, take the camera pixel and show how
see how it's not as wide as my head anymore. It's horizontally narrower.
Right, I'm telling you.
See how it gets wider and now it gets narrower, wider, narrower.
If you get the same camera and do the pixel thing, it's gonna be the same big on your video.
This is a camera, by the way. So currently my finger is as wide as my head, and now it's only as wide as my nose, or it's not even as wide as my nose. Why is it that if it gets closer, it gets wider, if it gets further, it gets smaller?
If you take the same camera with the pixel, like you did it with the sun, like you're showing me 684, if you do that with your hand, it's not gonna change size. It's gonna still the same pixel.
No, it won't. If the sun was actually getting further away, it would get smaller.
And it does.
But it doesn't, not according to the video I just showed you.
If you zoom into it and put this pixel thing, but if you go on top of the mountain, make a time lapse, you will see how it gets smaller.
How do you know that this wasn't done on top of a mountain?
Huh?
How do you know this wasn't done on top of a mountain?
Alright, just go on top of the mountain, grab...
How do you know this wasn't done on top of a mountain?
It doesn't matter, you're zooming in.
The zoom isn't changing in this video, you know that, right?
But you're zooming in anyways. You're not looking from an normal perspective.
Yeah, so the zooming in just makes everything bigger, right? It makes it bigger horizontally and vertically.
It just doesn't change size.
It scales up zooming in scales up everything, right?
Like your hand. As I said, if you film it with the video, it's not gonna change size. It's gonna be,
right,
for example,
in your view, so the camera's fixed. It's just pointing in a different direction depending on where the sun is. In your view, the sun starts out here. Sorry, it starts out far away, and then over the course of the day, it zooms overhead, and then it goes further away again. It should be changing size, but it doesn't. We just watched a video showing that it doesn't.
It doesn't prove anything.
It proves that the sun isn't getting closer or further away over the course of a day.
It is. You can see when it rises from...
Okay, so you're telling me that it does get further away over the course of the day, it just doesn't change size?
It moves on top of your head, and it's pretty far away. And there's atmospheric effects. There is a dome. And, you know, the floor is not curving. Earth is flat. God is real.
Amazing.
Flat Earth is only good things for your life, nothing bad.
You just blowing from Stupid Town?
And don't take vaccines also.
Oh, brother!
Now you can go next if you want, sir. I'm gonna go to the gym now, and don't forget, bro, the Earth is flat, man.
Do not come.
Fascinating. I hope his arm muscles are bigger than his brain muscles. Fascinating. All right, let's read some super chats and then we'll move on to our next guest. By the way, to everybody who sent super chats, you guys are very much appreciated. I do appreciate you guys. You help sustain me, sustain the live stream, give me reason to keep doing this. From Relax with Russell with the $5. Here's $5. Well, thank you. I appreciate that. From Lou with the $10 Australian. Yes, you've been modded. I mean, you deserve it. You've been here long enough. From the guy who does with the $5. Nah, you just don't understand the EFE and Abdelkader. Sorry for the troll. I figured I should donate as an apology and because I got spawn camped. I appreciate the apology. You can get unbanned. From Skeeter Sayer with the 10 Canuck bucks. All you have to do to prove the Earth is round is travel from the northern hemisphere to somewhere above the equator. You will find that Orion is directly above your head and not at a 45-degree angle. That's true. That's a good point. You can also notice that the North Star gets lower and lower and disappears once you go past the horizon. Or past the equator, rather. From Skeet Sayer, again with the 5 Canuck bucks. Where does Flat Earth even come from? The Catholic Church? No, it comes from this guy named Samuel Robotham in the 1800s. he started this whole thing in the 1800s, and it's basically all based on everything that he said. And of course, he referenced the Bible, but people weren't really flat earthers before him. I mean, the people were flat earthers like thousands of years ago, but like, it was his fault that this exists in the modern times. All right, let's bring up our next guest. Let's check to see if we have any. We don't have any guests on Discord, so we can bring up a guest from YouTube. Let's bring up Ahmad. Ahmad, how's it going?
All right.
I'm glad to hear it. Ahmad, what shape do you think the Earth is?
Let me just show you the evidence. I've got the evidence that the Earth
First,
is
I want to know what shape you think it is.
Flat.
Okay, great. Why do you think it's flat?
I've got evidence. Do you want me to show you?
Yeah, I mean, like, I won't be able to pull it up for all the guests, but you can tell me about it, and I can go pull it up, and we can look at it together if that's okay.
Yeah, so I'm just going to show you. This is the evidence. Trust me,
Mods,
guys.
Mods ban him. Gone forever. Gone forever. From Nuktuk with the 6 euros, maybe the sun increases in size as come to the noontime and gets smaller at night. That's why it's the same pixels on video. Yep, that would make sense, except there are different people from different places that see it at different times, right? Oops. No, I get that it was a meme. Let's talk to Gabe. Most intelligent flat earther I've talked to all day. Let's talk to Ty Atlas. Ty Atlas, how's it going?
Oh, good, thanks, man. Yeah, well done for this, Doctor. Oh, wow, cool. What's your PhD in?
Ty, what shape do you think the Earth is?
Oh, okay, you asked the questions. What shape? I am more inclined to think it's sphere, but NASA always makes stupid videos, so I'm a little bit confused with the budget and cameras. Like, I don't really understand why they don't just obviously stick on a decent camera on a rocket and have it streamed live. It's very easy. If you can make phone calls up there. If you've seen that god-awful movie called Gravity, you realize something is up.
No, I didn't see that movie. I just the only reason I asked is because I just didn't want to go down a rabbit hole before I knew that this was a conversation worth having. I have a PhD in physics.
Beautiful. Well done.
Right.
Nice.
So look, you do know that there are 24/7 live streams from the International Space Station with cameras pointed at the Earth, right?
Space Station, yeah.
Okay, so like, why isn't that enough?
Because it hasn't cured the pandemic of ineptitude across the board.
Well, I'm not asking why. I'm not asking why it's not enough for other people. I'm asking why it's not enough for you.
Because I'm still skeptical about man's competence to do anything beyond pursue its own ego. Really.
Okay.
We're
skepticism.
pontificating.
I mean, there's evidence against the skeptical claim here because we do have a 24/7 live cam from the ISS. We have photos taken every 10 minutes from weather satellites that are tens of thousands of miles away. And you can go check that the weather satellites, they have pictures of the Earth. You can go check that the clouds that they're seeing are the clouds that you're seeing. So it's just not so clear why you would be skeptical of this unless you have some underlying motivation.
Underlying motivation? Well, it doesn't really do anything to help the world's problems, really.
That's not related to whether or not it's real.
Yeah, with all the astronauts going up there saying when they look back at the Earth, they realize it's all just one big blob and we should all care about one another. That's quite a holy message. It's quite like a profound message of...
Oh, I'm getting told that that you usually sound like a Southern guy.
Southern what?
What part of the world are you from?
England.
What part of England?
Born in London.
Born in London. All right. Londoners, if you're watching, confirm that his accent is a London accent. Anyway, go ahead.
Lying.
Well, somebody in the comments has suggested as much. I just want to verify.
Well, that I could be a shapeshifter.
Yeah,
Lying.
indeed. Do you know what time is it in London, by the way?
7.
Okay, I believe that. Yeah, okay, so look, sorry, it's just, people give me some degree of skepticism because a lot of people come up to troll. So look, It just
No,
seems
I'm
like
not trolling you. I'm genuinely, I'm a learned man in the spiritual sense. I spent 8 years playing, traveling the world because I was able to understand liquidity grabs from the market. So I've spent a lot of time in conversation with people, and it's bizarre how people
I believe you.
still don't know.
So you think the Earth is a sphere, and yet
Yeah,
you're
I guess so.
skeptical
I don't
of the
care.
NASA
It doesn't
stuff.
really do anything for me. It's not gonna stop me from sleeping at night.
And
I have no bearing.
And
I
yet
have
you're
no-
skeptical of the NASA stuff. So what
I'm
kind of
skeptical
evidence
of the
would you
amount
look
of money
for?
that's spent, the amount of money that's spent there, and what's happening to the state of America politics is just shocking.
Why are you
It's
skeptical?
embarrassing.
So do you think that the amount of money is not enough, or do you think it's too much?
I don't think America knows how to look after its people. It's quite embarrassing.
So do you know how much money is spent at NASA?
Ooh, a lot per year.
Yeah, do you know how much?
In the billions, I would imagine. 60, let's say 60 billion, 30, 60 billion.
Depending on the administration, of course.
How about you tell me?
It's something about, it's around $20 billion. Now that sounds like a lot of money, right?
I was out by 300%.
It sounds like a lot of money. That's like $65 per person per year.
Per year.
Yeah.
Because the GDP of America is...
No. I'm just taking the total population and dividing the budget by the total population. So each person spends about $65-ish per year on NASA. Compare that with the average tax bill.
AI. That's hilarious.
What?
Wow. Some fool said on AI. That's funny.
So compare that with the average tax bill of, the middle class or whatever that is, and you'll find that like $65 per American is actually remarkably low as far as the total costs go.
I would spend it on healthcare. I would spend it on
$20 billion wouldn't be a drop in the bucket on healthcare. If you want to, I agree. Yeah, $20 billion would be a drop in the bucket.
There's a big difference between million and
I said billion, but it may have just, at least I thought I said billion. The comments will decide. But all I'm saying is that $20 billion is a drop in the bucket for the healthcare required for the United States. I think that it's been estimated that it's like $10 trillion would be required for a healthcare program in the United States, which is a lot. Now, here's the thing. Lots of other countries have space programs, and they all come to the same conclusions that NASA does. So it seems like that this criticism that like, they're spending a lot, and they shouldn't be. I guess I just don't even understand what the criticism is. It's not a large fraction of the U.S. budget. It's not enough to cover really anything important.
Most of the conspiracy theories come out of the Americans.
Well, and I've spoken to a lot of British people who are flat earthers.
Really? Oh, I've not met them. Maybe Burning Man. I saw a couple of bizarre people. Yeah.
But it just seems like your skepticism here, like, where is the skepticism originating from? Like the skepticism about NASA. You said that they came out with a whole bunch of funny videos. Like, where is that skepticism coming from?
Yeah, just the astronauts seem dumb. They don't seem like they're not versed in public speaking.
Why would they be?
There's an air of that Artemis Perry bizarreness of not having a camera inside.
They
not
did
having
have
a camera
cameras inside.
No, it didn't. It didn't. And the way the door.
What do you mean? No, it didn't. We have there are cameras inside. We have videos of them speaking from inside the capsule.
Yeah, for a period, yes. And then when it went up, it was just sound.
What are you talking about? Like we have videos of them while they're going around the like making their way to the moon. We have video of like all this stuff.
With the camera showing
the camera being inside, pointed at them. Like they did like interviews and stuff.
With them pointing the camera at the moon. I didn't see that.
No, the camera's inside, pointing at them.
Yeah, with the moon in the backdrop, right? To determine where they were in location.
I suspect not. If you want to see things in space, then you have to turn off the lights because the lights are really bright. And so you're probably not going to get a good video of the astronauts and also be able to see what's going on in the backdrop, right?
Sure, but when you point a camera in the pod at the moon, you'll see the moon, right?
Yeah, I think that there's like photos and videos of this.
Oh, I've not seen them. I saw some news channel giving a feed with interviews and the way in which it was.
There was a thing that Hank Green put together. Let me
I
see
don't.
if
I
can
don't
find
do a
it.
lot of live streams, so maybe I've missed a website that was depicting the live feed of it.
Let me see if I can find it.
This is just information that I saw on the news, and the news seemed bizarre.
Let me see. Let's see.
You are a physicist. I can tell.
I don't know what that means, but I'll take it. Here we go.
Super fast with a keyboard.
Oh, that's not a physics thing. That's just I grew up with playing computer games. So here we have some photos, and in particular, this is what I'm looking for.
Where are these photos? From the Artemis?
Yeah, here you go.
Yeah. And I guess that comes from a video, right? That seems so poor quality. It's a snapshot.
I
from a video.
actually don't know.
Yeah,
Here's
looks,
another.
looks poor.
This is just a photo.
Yeah, I didn't realize there were women and men on the journey. I thought there were 5 females or however many females. I didn't realize
Wait,
men
you
went.
didn't pay attention to any of it. There were 3 men, 1 woman. How do you not know this?
The Artemis Katy Perry thing?
Artemis was not Katy Perry.
What was she? What was it called?
I was like, I don't
Blue.
know. She didn't even.
Yeah, that's
she didn't even
right.
go
Some
into. She didn't even like go. She didn't go to the moon.
Oh, wait, hold on. That's what I'm talking about. I'm talking about the Jeff Bezos.
That's not Artemis.
No, what is it?
I don't know.
Oh, are you not aware that Katy Perry
No,
went...
I know. I just don't know what it's called. It's like I
there you
know
go,
his
that
company is
makes
called
two of
Blue.
us.
I know his company is called Blue Origin. I just don't know what
Well
that
done.
mission was called.
No,
Does anybody know
I
what the
thought
mission
it
is
was-
called? Oh, Blue Dragon. Somebody said.
Blue Origin.
Well, Blue Origin's the name of the company.
Blue something. Yeah, there you go. That's what I'm talking about.
New Shepard, maybe.
Okay, that's biblical.
I can just look up Katy Perry. Blue Origin NS31, New Shepard. Okay, what about that? They didn't
Yeah,
even they didn't orbit the Earth or anything.
No, but they went up, right? They went up
That
into
wasn't
space.
NASA. So I thought we were talking about NASA. You were talking about like all this sketchy NASA stuff. That wasn't NASA. That was Blue Origin.
The sketchy NASA stuff would be the videos and the bubbles and
So
the
then why'd you bring up Blue Origin?
green screens. Oh, the same thing. There was something not
But that's
quite
not
right.
NASA.
There is it's a rocket, right? It's
Not
about
all rockets are NASA.
we're still talking about flat Earth.
Not
and
all
supportive
rockets are
evidence.
NASA.
We're talking about flat Earth.
Yeah.
Let's go back on topic. We're not talking about a particular
I'd love to be
company. We're
back
talking
on
about-
topic. But your skepticism when you first came up, you said that NASA
There you
does all
go.
of these funny videos, right?
Let's go back to why I'm skeptic. Skeptic.
Yeah. Am I correct in saying that you think that NASA has all these funny videos?
NASA does, and so too did I think that blue video. I thought that was something quite bizarre about.
Okay, so can you give me an example of like a NASA video that you think is funny and not compelling?
Okay, I'll drop the Katy Perry. The green screen glitch-like feeds that you get on these collection videos of people trying to convince
Collection
you
videos?
it's flat. Yeah, you know when some
Yeah,
a
so
journalist
there's a
has
famous
done some
one.
conspiracy piece.
Yeah, so there's a famous one where like a thing is drifting in front and then you see like a glitch on like the thing. You know what I'm talking about? There's like a little, it's like a stuffy doll or something like that, and like there's a green screen that like appears on the stuffy doll's like body. You know what I'm talking?
You probably know this as a data statistician or a physics man who has access to research. How many people believe in the flat Earth against those who don't?
Depends on where
against
you
those
are.
Like
in
me?
the United States, it's about 10%.
Wow, that's little as that.
That's enormous.
They
That
make
is
quite
like-
a fuss.
What?
For as little as 10% of the population, they make quite
They're
quite a fuss.
loud. Yeah,
Wow.
but they're.
Yeah, that's bizarre. I wonder what they're drinking.
That's a good question. But look, I'm going to let you go because you're not a flat earther. And I hope that I've at least given you some information that you can look up for yourself to assure yourself that these funny videos are probably not actually funny videos. But thanks for being here, Ty. He was pleasant enough. It's definitely the British accent. It's just, it entrains me. But let's bring up the Crypto Bros. Oh, let's read some super chats first. Sorry, then we'll bring up the next guest. From Mr. Kiki with the $5. So we're just using the we're just used to hearing from the unemployed FLERFers the Memorial Day weekend is bringing out all the employed ones, and it's somehow worse. It is somehow worse. From C-Bar with the $2. Thoughts and prayers, much appreciated. From Skeet Sayer with the 2 Canuck bucks, propaganda is why we are here. Indeed. That's what the Brits call it when you take a good look at something. From Karen with the $2. Today is about the real heroes. Yeah, not the flat earthers. 10% of the US is crazy. Yeah, it is. That is crazy, and I can show you the poll for it. From Skeet Sayer with the 2 Canuck bucks. Maybe he means the movie Hidden Figures. Who knows? From Jim Daniels with the $10. Very much appreciated. Congratulations, China, on your successful launch of the Shenzhou 23 spacecraft. Safe journey to the 3 taikonauts on the way to the Tiangong space station. I didn't even hear about that, but congrats. It's a global effort, right? We shouldn't take national disagreements to be proud of the human race. From Skeet Sayer with the 2 Canuck bucks, show him a pic of the Pillars of Creation from Webb. I can, but I don't know if he'll find it compelling. And from Game Master Flash with the $5, Ty called you Physics Man. Are you actually Physics Man? Take off your glasses and let us all see the truth. Thanks for using your powers for good. All right, here we go. We'll take off the glasses of hypnosis. I look the same. Turns out I look the same. All right, let's bring up our next guest. Let's talk to the Crypto Bros. The Crypto Bros, how's it going?
Good, good. How are you?
I'm doing all right. Crypto Bros, what shape do you think the Earth is?
I think it's flat.
Why do you think so?
Well, when I look at the cosmology of every ancient culture, they all have a similar cosmology.
Okay.
The only one that's different is the heliocentric.
Yeah, and then so when you look at like modern cosmology that's driven by data and the scientific method, you get something that's different from that. So why would we trust these ancient cosmologies rather than, you know, modern cosmologies that use the scientific method and data analysis?
Well, I think a lot of these institutions are lying.
Sorry, what institutions?
The institutions that are recording the data that we're going by.
Sorry, which institutions would those be?
Well, okay, so first and foremost, I think that NASA is lying.
NASA doesn't record cosmological data.
I think, let me, you asked me what institutions.
Well, yeah, you said these were the institutions that were recording the astronomical data, which is what we were talking about. Right, so presumably you're going to give me some institutions that you think are lying for reasons about the cosmological data.
What I think is that whatever institution records the data is that they are lying. I think that there's
why do you think that these are even institutions that record this data?
I'm sorry, could you repeat the question?
Why do you think that there are institutions involved at all?
Well, there needs to be institutions.
To do science? No, there doesn't.
Well, people want to know, people are curious. I think that there
You don't need an institution to do science.
Well, institutions are for control. That's first and foremost.
But we're not talking about institutions. You can record this data without institutions.
How? Well, I mean, obviously
you can have your own telescope.
Well, yeah, but institutions, what they do is they have historical records and they log everything, they record everything. So it's a lot more efficient than just one person.
Taking these institutions,
an observation and recording.
So in the, what was it, the 1500s? Or no, I'm sorry, it's the 1700s. In the 1700s, when Copernicus was doing his thing, it was the 1500s. In the 1500s, when Copernicus was doing his thing, there were no institutions. There was no bureaucratic state. There was like a king, and Tycho Brahe, however you pronounce his name, he owned his own telescope and he recorded his own data. And
so,
Kepler,
yeah, but if you knew,
I think it was Kepler, not Copernicus. Kepler.
But if you knew history and you knew what was going on in that time, the Roman Empire, they fell in the mid 1400s. The Moorish Empire fell in 1492. And so there was a lot happening in the world around that around that time. But there still were institutions because at that time the kingdom, the
It was
kings
Kepler, not Copernicus. I'm sorry.
their men, they acted, you know, in the churches, they acted as what institutions do today.
Okay, so Tycho Brahe, he was just a guy, a fairly rich guy, but he was just a guy who owned his own telescope. He had a few assistants, and that's how they collected data. Where's the institution?
But you can go back.
Tycho Brahe's data is how we got to the Copernicus, or is how we got the Keplerian model that we, you know, now use. It was from Tycho Brahe. That's why I'm referring to Tycho Brahe.
But if you go back further, I mean,
why are we going back further if we're talking about like Kepler's laws of motion and, you know, elliptical orbits and so on?
This is what you brought up. What I'm talking about is the cosmology. Why
I know
is it that
the cosmology, the heliocentric cosmology, really goes back to like the 1500s.
Exactly.
Maybe the 1600s or so. But the point is that there were no institutions in the way that. No, you're right. He didn't even use a telescope. He just used his eyes. You're so right, because the telescope wasn't invented yet. So bro just looked at the sky and recorded data. That's so true. I forgot about that. You're right. So like, where's the institution here?
Prior to the 1500s. Remember what
Prior
I said?
to the 1500s,
Rome fell in the mid 1400s.
That's cool, and that's cool and irrelevant. The point is you're saying that
it's relevant.
I can explain why I think it's irrelevant. Your claim is that the institutions are lying to us, and so we can't trust the institutions, and it's from the institutions that we get our data. But Tycho Brahe and his assistants, one of whom was Johannes Kepler, they weren't part of an institution. They were like a scientific duo, and they were just looking at the sky and recording that data, and that's how we got to the Kepler model, right?
Because what modern institutions do is they take the data and analysis of past people that had great minds, such as Newton, such as the person that you're talking about, and many others, and they put that as the staple in the institutions, which is why Vogt, like when you measure Vogt, is named after the guy Vogt, which is why we say the Newtonian.
Look, the point is that Johannes Kepler used the data that Tycho Brahe came up with to confirm his version of the heliocentric model, right? Mm-hmm. This isn't something that somebody 100 years ago or 50 years ago did that involves modern institutions.
I'm agreeing with you.
The heliocentric model of Kepler came from Kepler 500 years ago when there were no institutions around that were, you know, governing their whatever, right? They were just like two guys and some assistants, of course.
Who was he funded by?
Who was Tycho Brahe funded by? Well, originally he was funded.
Who was backing him?
Originally, I guess he was funded by the King of Denmark, but then he was forced to leave Denmark, and so then he was invited to Prague, and then he worked in Prague.
The king.
And he built he built an observatory. No, he was forced to leave Denmark by the king. The king forced him out.
Power.
The king forced him out.
Well, at one point they had a connection, so that's still going to.
I mean, that's not clear to me. I don't know if that's true.
Because that's going to amp up his credibility.
I don't know if it's true that they actually had a connection. But the point is he made these observations himself, right? So where's the institutional lies?
Okay, so that was the history of it. What institutions do is they take historical figures and they use their data in the institutions that are now existing today.
Okay, and but they knew that the Earth went around the sun 500 years ago. Well, 475 years ago.
You keep saying 500. Go prior. Go before that. Because what I'm saying.
My point is, it doesn't matter what's going on today, and it doesn't matter what was going on 2,000 years ago. We collected the data as a species. We collected the data about 500 years ago, and that's what led us to the conclusion that the Earth goes around the sun.
So, are you telling me that you believe that institutions do not lie?
I'm not. I never made that statement. What the institutions say is irrelevant to whether or not we go around the sun.
We need to start back from ground zero. Prior to 500 years, every culture, their cosmology, did not.
Well, that's not true.
Yes.
If you go back maybe 2,500 years ago, sure. But starting around when Jesus lived, like around the 1st century, we see that we see globe models.
I've done research on
globe
this.
cosmologies.
Yes, look, but what I'm saying is that it looks like a snow globe. The bottom is flat.
No. I mean, prior to maybe 2,500 years ago, that's true. But after around the turn of the millennium, around when Jesus lived, we start seeing actual globes, not snow globes. The Vedic texts are far older than 2,000 years old.
Look up the Vedic cosmology. Look up the Vedic cosmology. Look up the Chinese cosmology.
Why are we only going back like more than 2,000 years? Why don't we look at anything from the last 2,000 years?
Oh, that was the Vedic, wasn't it?
The Vedic stuff is far older than 2,000 years.
You said you want to go back.
No, I'm asking, why are we only looking at things that are more than 2,000 years old when we can look at stuff that's more recent that is obviously going to be more accurate?
Because this is my point. Is what I'm trying to explain to you is that about 500 years ago, that's when we have been conned. We, as in humanity.
Well, no, I mean humans have known that the Earth is a globe for around 2,500-ish years.
No, that's not true.
It is true. Yeah.
No, that's according to the history that you believe.
Oh, okay. And you have your own version of history, right?
No. Look. Just
can I show you something?
Steve Jobs.
Don't care about Steve Jobs,
please. No, let me just say one thing.
Seems irrelevant.
Steve Jobs said that the most influential person is the storyteller, because the storyteller he has the most influence over everybody. What is history? History is a story. Everybody gets different versions of it. And
do you know who Pliny the Elder is?
I'm sorry, repeat that?
Do you know who Pliny the Elder is?
No, I don't.
So Pliny the Elder is one of humanity's most famous historians, right? He was Greek. He lived, a few decades after Jesus did. So this is, during the Roman era. And this is his book. Of course, it's translated to English. This is one of his books that he wrote. It's called The Natural History of Pliny. And then here's the people who translated it. So I'm going to go to a particular page.
Okay.
Chapter 2, Of the Form of the World. Again, this is a guy writing about 2,000 years ago. That it has the form of a perfect globe we learn from the name which has been uniformly given to it, as well as from numerous natural arguments. For not only does a figure of this kind return everywhere into itself and sustain itself, it also including itself, requiring no adjustments, not sensible of either end or beginning in any of its parts, and is best fitted for that motion with which, as will appear hereafter, it is continually turning round. But still more because we perceive it by the evidence of the sight to be in every part convex and central, which could not be the case were it of any other figure. So this is a historian, one of the most respected historians of all time, talking about the Earth being a globe 2,000 years ago.
Now, I would say that that's credibility right there. But then I can also throw something back at you and say that there are maps that are drawn from credible people as well. And on those maps, they have creatures and mermaids and things like that, which I know you wouldn't believe. So just because somebody has credibility.
This is a Roman poet from around 70 years earlier than that. Ovid, you've probably heard of him if you're familiar with literature. So here is, this is the Metamorphoses. This is describing the creation of the Earth. And so we have book one of the Metamorphoses. This is sentence 32, section 32. It's not really verse 32, but it is what it is. So when whichever god it was had ordered and divided the mass and collected into separate parts, he first gathered the earth into a great ball so that it was uniform on all sides. Then he ordered the seas to spread and rise in waves and the flowing winds and pour across the coasts of the encircled land. He added springs and standing pools of lakes and contained blah, 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 blah. So this is right. This is while Jesus was alive. This is Ovid talking about how God, whichever God made it, created the earth into a great ball. This is 2,000 years ago.
It's flat at the bottom and round on the top.
It's a snow globe. No, it's a ball, not a snow globe, and it's uniform on all sides. If it was a snow globe, it wouldn't be uniform on all sides.
How about you read something from the Vedic or something from the ancient Chinese?
So
because
look,
when we look up history, we only look at it from a Western point of view.
Here's the reason
There's
why I'm
so
bringing
many
up
other
Ovid and
cultures.
Pliny the Elder. The reason why I'm bringing up Ovid and Pliny the Elder is because Ovid and Pliny the Elder lived in a Greco-Roman culture, and it was the as far as I know, it was a particular Greek person named Eratosthenes who provided the first compelling evidence that the Earth was a globe. And this would have been about 250-ish years before Pliny the Elder or Ovid lived. And so it's going to take time for these ideas to spread, which is why we have Greco-Romans talking about this only a few centuries after this evidence was first presented. Now, if you want to go back 3,000 years, everybody thought the Earth was not a globe because they didn't have the evidence that it was a globe. The first evidence came around about 2,300 years ago. So if you look before that, then nobody's going to believe it's a globe.
So you bring up Greek literature, and according to Greek literature, someone in it, they said that Atlantis existed. So are you saying that Atlantis
Wait, you mean
existed?
are you talking about Plato talking about Atlantis existing?
Yes.
So
yes,
he was so that was in an allegory, right?
And
he didn't say Atlantis was a real place. This was an allegory.
It's based on the way that it was said.
Wait, hold on. Have you we can pull up the document if you want. Have you read the Plato's work that involved?
Long time ago, back in like sixth grade.
Which books were they in?
I don't even recall, to be honest with you. Long time ago.
I don't think that you read it. For what it's worth, I haven't read it either. I've just read snippets.
I just told you that I did. So regardless of what you think, I told you.
Well, okay, but then you would probably know, at least what book it's in.
I don't mean to lie to you.
So it's mentioned in. Apparently, it's mentioned in Timaeus.
Right.
Apparently, it's mentioned in Timaeus. And so, and as far as I can recall, this is like a story that's being told. They're musing about what a perfect society is, right? This is like, well, this is what a perfect society would be like. So there's a reason why we know that Atlantis wasn't something that people thought really existed, right? Whereas the stuff that Pliny the Elder was a historian. He's one of the most reliable historians that we have from that period. And, he's talking about how it's obvious that the Earth is a globe. We all know it's a globe.
That's because of who you believe. You only believe Western information, and if you were to look up many other cultures,
the
you
Chinese,
see a common denominator. You would see a common denominator.
Hold on one sec. I bet you I can find within 30 seconds an ancient Chinese source that says that the Earth is a globe. I bet large sums of money.
Look, I have here on ChatGPT right now what it says about Atlantis.
ChatGPT, famously a reliable source.
And what Plato said about Atlantis.
I'm not here to debate ChatGPT for what it's worth.
Okay, fine.
So, look, all I'm saying is that it seems like you're dismissing sources that are known to be reliable.
I'm
and
not.
Then you're
I'm agreeing.
Okay, then why did you dismiss Pliny the Elder?
I know what I said is that you can bring up anybody from that time and say that they have credibility, and that's the reason why I brought up Plato. And then I asked you, do you believe what he said?
Right.
And then
but
you said
Plato
it was
wasn't a historian. The discussion of Atlantis was about like a utopia society, utopian society. It wasn't described as like a real place.
But Plato is someone that has credibility.
Yes, and his credibility is not in history. His credibility is in philosophy. And in the works in which he's talking about utopia, Atlantis, he's not talking like this is a story that he's telling to convey an idea.
You want me to tell you what ChatGPT says?
I don't really care what ChatGPT says. No.
Okay, then fine. The thing is that there's a common denominator with all cultures and their cosmology.
Apparently not all cultures. No.
Prior to about 500 years ago.
No, I just gave you an example of one from 2,000 years ago.
Well, I've done extensive research with many different cultures.
So the Greco-Romans of the early Christian period, that's an ancient culture. That's 2,000 years ago. They knew the Earth was a globe.
Do you find it strange that Antarctica is blocked off?
It's not.
Have you ever thought about that?
It's literally not blocked off.
Well, it's blocked off to regular people.
No,
and,
it's not.
And it's blocked off to commercial vehicles going
No, it's
down
not.
there. You can't take any trips down there.
What's your evidence for that?
Vehicles.
What's your evidence for that?
I watched a documentary on it yesterday.
What's the evidence? You can just say you watched a documentary.
Okay.
What's the actual evidence?
Well, okay, let me look it up on ChatGPT right now. I have it right in
Oh
front
my
of me.
god. Okay, so just so you know, are you aware of the Antarctic Treaty? You familiar with that?
Yes.
Okay, so the Antarctic Treaty.
Yes.
I've read through the whole thing. It doesn't say anything about you're not allowed to go there if you're a civilian. It's freely available. You can go read it yourself, but you won't, right? Because it's not just an AI summary, right?
No. Okay, you're absolutely correct. I stand corrected. The information that I must have gotten I must have been uninformed or uninformed. So yeah, you're right.
In fact, not only can you go to Antarctica, there was a team of flat earthers and a few globe earthers that went to Antarctica about a year and a half ago. I think it was at the end of 2024, in December of 2024. They went to Antarctica to see if the Earth was really flat, because if the Earth was flat, they shouldn't have been able to see the 24-hour sun in December. That was the idea, and there are a lot of clips of very famous flat earthers who, before this happened, they are on record saying they will never let us go to Antarctica because we won't see a 24-hour sun because the Earth is flat. If the Earth is a globe, then we will see a 24-hour sun. If the Earth is not a globe, we will not see a 24-hour sun. And what did they do? They went to Antarctica. Flat earthers went to Antarctica. And when they got there, they saw the 24-hour sun. They recorded the whole thing, and at least one of the flat earthers is no longer a flat earther because of it.
Interesting. Let me ask you a question, because I know you're about to let me go.
Sure.
Let me ask you a question really quick.
You have 20 minutes if you want to stick around.
Thank you. Okay. Are you religious? Do
No.
you have a religion?
No.
Do you believe in God or anything like that?
No.
Okay. So you're strictly scientific. You go strictly by the scientific method.
Yeah, at least I try to. I mean, nobody's perfect. So, you know, there are things that obviously that I could be better about. But yeah, I try to do my best to believe things that we can provide evidence for.
Observation, hypothesis, prediction, experiment, conclusion.
Yeah.
Do you believe that in order for us to come to an understanding, at first we have let's say something like insight, and then that insight leads into data, and then data leads into information, and information knowledge, and then perhaps wisdom from the knowledge?
That sounds like a bastardization of the scientific method. So it's close, but like there's some testing that needs to be done, right? That's where the data comes from.
Because what I'm getting at is when we see patterns, patterns would be the insight, and then we would derive data from those patterns. So if I'm looking up many different cultures, many different walks of life, and there's a common thread, there's a common denominator, that will make me scratch my head, and that's why I am thinking the way I'm thinking.
And you're right. So we should absolutely ask, why is it that these ancient cultures, you know, prior to like 2,500 years ago, why is it that they thought the Earth was a certain way? And if we think about it for even half a second, it's because it looks that way, and they didn't have any better method to figure out what shape it actually is. That's why. That's why they all believe that, because it looks that way.
But this is why I don't believe it, and this is because whenever a civilization is conquered, all of their books and everything gets, you know, torn up, burned, whatever, destroyed.
That's not true.
But the thing about, well, most of the time, right?
No.
You don't think that when a civilization is conquered, that the conquerors, what do you call it, their language and their religion gets instituted into that?
Yeah, famously
region?
not. I mean, like the Mongolians famously let people practice whatever religion they wanted to practice as long as they paid their taxes. Okay. And they like conquered like half the known world. Similarly, so did Alexander the Great. Like, you could be whatever.
So this would just be some religions.
It sometimes happens.
I mean, I'm sorry, not religions. Some countries. Or
It
whatever.
sometimes happens that some conquerors will like burn everything to the ground. Sometimes, but I don't think that's the norm.
Because I find it fascinating that a lot of the Indian stuff is preserved, and the reason why I think that is because of Gandhi, and he, got the British out of there before, they,
Wait a minute,
they
hold
obviously
on.
came, but they didn't stay too long.
Well, no, I mean, they were there for a really long time. The point is the British conquered them, right? It was a very weird kind of conquering. It was like an economic conquering with like soldiers backing it up. But no, that's neither here nor there. The British conquered the Indians and didn't burn down all of their records. So that's a perfect example of stuff that's against your claim.
Well, no, that's what I'm saying. I'm using that to support my claim. And what I'm saying is
Your
that
claim is that they get rid of all of the books and stuff, but that's not true.
No, but I'm saying it has not happened in India, and that this stuff is preserved, and that when you really look at it, when you really dive into it, like I'm inviting you to dive into it. Like, look, my mom
I've read
has
the
her doctor's
I've
degree.
read the Bhagavad Gita.
Well,
I've
I'm not
read
talking
some of the
about
Vedic texts.
Okay, good. I mean, dig a little bit deeper. Look into the Mahabharata. Look into the Upanishads. Look into some of these
I've read the
texts.
Upanishads. I read them in college.
Cool.
They're
Cool.
interesting stories. They're interesting and in some parts very deep, but they're not there to make scientific claims.
Yeah, but when you look at their cosmology, did you take a look at that? And the way that they describe it with the
and
that it has 14 levels.
Look, yeah. The point is that they had a cosmology based on their religion rather than based off of the evidence in the world around us.
But isn't it interesting that they had levels, and then when you look at other cultures, they had levels as well too, saying that the Earth
Having
is
having hierarchies is very normal in human society. So it's not surprising that there would be some sort of hierarchy system in their cosmology.
But in so many cultures across a long period of time, that's a pattern.
Yeah, and then we can investigate why, and it turns out it has a sociological explanation.
And what is the
sociological explanation that humans crave hierarchy?
No, not every culture. Not every culture. Not like
Give me an
that.
example of a
Then
single
how-
culture
then-
that doesn't have hierarchy.
Then how come our cosmology is the only one that's different?
Because we're relying on data rather than sociology and human nature.
Yeah, I mean, I understand that we're not going to.
Why are you averse to using data and to using the scientific method to figure out the facts of the world around us?
Because I don't trust these institutions.
You don't have to
And I
trust
don't trust
institutions.
the
We've been over this. There are no institutions involved in the early days of the heliocentric model. You should just actually look at the data rather than just believing what long dead people said.
I've looked into it, and
Apparently
I'm not
not.
too good at. I'm not too good at explaining things, but I have a beautiful mind when it comes to me just internalizing. But when it comes to me explaining it, I do better with writing it down.
Okay.
Honestly, that's just the way I am.
All right, Crypto Bros, I'm going to let you go, but thanks for being here.
Thank you.
By the way, just to be clear, because somebody was pointing this out in the comments, it's absolutely the case that there are a lot of cases where conquerors did destroy the cultures of the conquered people. That's just not... That just definitely didn't happen every time. I'm not even sure if it happened most of the time. There are just very famous examples of it happening that, we have historically documented. All right, let's read some super chats and then we'll bring up our next guest. From Skeetsayer with the 5 Canuck bucks, the institution was the church. Before the printing press, they were the only ones that could read. The institution, so famously, Galileo was put in house arrest because he defied the church. So he was fighting against the institution with his heliocentric model, right? From Hercules with the 11 euros, regarding ancient civilizations, the Greek knew the Earth is a globe since about 300 BC, and we can see that in depictions of the god Atlas holding the globe. Weird how flat earthers do not mention this. Right. That's exactly what I brought up. I didn't bring up the statues, but like this is like clearly what they thought. From Jack Vetter with the $5. Tupac actually referenced the Pythagorean theorem in the track "I Ain't Mad at Ya." Friggin' propaganda from the corporate machine, right? Tupac is part of big math. From Carl Grimes with the $20, very much appreciated. I appreciate you so much. It's big donations like this that help keep the channel running. Black men are prime targets for the FLERF political movement. White supremacists, no black men have been targeted by our institutions historically. They are seeking to exploit that for their own anti-science goals. Shame. Yeah, that is true. It's absolutely the case that, you know, the United States especially, but much of the Western world has done unmentionable things to, you know, the black population with living within their borders. In the case of the United States, black Americans and this, you know, and so on. And so there is some natural distrust there, which is reasonable. But keep in mind, the distrust is in, the distrust should be in the CIA. It should be in the FBI. You know, the FBI, it was the FBI that killed Fred Hampton, right? It wasn't NASA. So like, NASA, as far as institutions go, probably pretty good. From Jack Fetter with the $5. I just found out we know of alien structures. That was from the movie 2001: A Space Odyssey. Ah, you got us. You got it. From Geraint with the $10. Heliocentrism is far older than the Copernican revolution. Greek astronomer Aristarchus of Samos figured it out 2,300 years ago. The idea didn't catch on, but he was still way ahead of his time. Yeah, well, sure. But, I mean, the Copernican revolution is what made it kind of spread everywhere. From Gretchen with the $3.11. I've done extensive research with many different LLMs. Yeah, let's not. From Skeet Sayer with the 5 Canuck bucks. All of these callers need to smoke a joint and watch web images. Maybe? From Skeet Sayer with the 5 Canuck bucks. Are you serious? Look at Africa and the Americas under Euro influence. Yeah, so the colonial period, the European colonial period from like, I guess that's starting in like the 1400s and going until like the 1800s, maybe early 1900s. That is probably the most explicit example of an invading power kind of destroying the cultures of the communities that, or of the places that were invaded. But like, that's not all of human history, right? Like, human history is far, far broader than that. From Skeet's Air with the 5 Canuck bucks, the Spanish unalived an entire continent and called them human sacrifice people. Well, look, okay, so obviously it's not the entire continent. Let's not be hyperbolic. It was a lot of people, but we know it wasn't the entire continent because we can see the genetic ancestry of like what happened is really that there was mixing between Spaniards and the indigenous people, and that's how you end up with, you know, like, I don't know, like the Hispanic ethnicity, basically. Hispanic isn't really an ethnicity, right? Like, there's Hispanic, there's Latino, it's confusing. The ethnicity that's present in Central and South America, and to a lesser extent North America, is different than what's present in Spain, right? And like, you can just, you can see, like, there's a whole spectrum of people, right? You'll see people that look very obviously European in Central and South America, and then you'll see people that look very obviously indigenous, and you'll see everybody in between, and it's because there was a mixing that happened. From Dockin with the $2, confirmation bias isn't research. That's true too. Wait. Oh, okay. All right, let's bring up Lana Del Pork Sphere, a salad.
Hello?
Lana Del Pork Sphere.
Yeah.
How's it going?
Good. So
what
I've been listening.
Is?
I think it's flat. So I've been listening since the British guy was in here, and I wanted to do his argument justice because he mentioned he had distrust with NASA, and that's perfectly reasonable considering all the shit that they failed to make look real. So one great example is if you look up NASA Dark Side of the Moon video on YouTube, it'll be the first video by ABC News from 10 years ago, and you can just tell this video it's fake as fuck. And
from ABC News, you say?
Yes, from 10 years ago.
So it's NASA Dark Side of the Moon, right? Is what it's called?
Yeah.
NASA Dark Side of the Moon.
And in
It's
this
from
video,
ABC News. Okay, I see it.
yeah, in this video,
We're just gonna put it up right now.
Yeah,
I can't have the sound on, but here we go.
that's fine. That's fine. Right here,
Yep.
you'll see.
These are photos, by the way. These are just photos that are put sequentially.
Well, the way you can tell it's fake is that the clouds don't move at all over a period of which should be hours of the moon rotating around the Earth on that model. The clouds don't move at all. They're the exact same shape. So this is clearly a digital animation that NASA is putting out there and trying to pose as being real. This is not real.
How long do you think that this was taken over?
It doesn't matter. It would be taken over hours if this was
How do you
real,
know?
Because the moon is rotating around it.
No. This could also be the perspective of the spacecraft moving, right?
Yeah, but the clouds will be moving. Like from Earth, we see clouds moving all the time.
Right, but they move slowly on a global scale, right? They move at like 5 or 10 miles an hour, which we wouldn't notice here.
I'll tell you what, they don't change the same shape, and the shape, the way they move,
sure?
it wouldn't be as if you're just rotating the Earth.
Well, I don't know how long this was taken over.
Also, keep in mind,
we can go see if we can find that information.
No, go back.
I'm gonna go see if I can find like where, like, you know, because these are photos. We'll have timestamps, right?
My second point with that video.
Okay, so you don't want to go deeper, do you?
No, you can. I'm fine with that. But my second point with that
so...
video, is that on the so-called dark side of the moon, there is less craters than from the front side of the moon. That does not make any sense at all. If it was the case, because how would there be asteroids and meteors hitting from our side of the Earth, the Earth and the moon, rather than the backside? It makes more sense.
Oh, so you just don't understand how gravity works. Yeah, so the Earth has a lot of mass, so it's going to pull stuff towards it, and it's going to pulse, but not everything that is pulled towards the Earth is going to hit the Earth. Some of it will just pass by, swing by, and then crash into the moon.
Also, well, sure, but there's still like barely any craters on those images on those.
By the way, there's craters. There's so many craters on the backside of the moon. They're just small. They just tend to be smaller.
Well, also that the quality of that video is shit, right? I think you would agree with me.
I mean, okay, it's like 8 stills over the course of. By the way, it was taken by the Discover satellite. Apparently, that's where the images come from.
Do you accept the possibility that it wasn't taken at all and it was just an animation?
No, I think that your burden of proof is pretty high for that one. Also, apparently, so those photos were taken over the course of less than 4 hours.
But the clouds don't move at all.
Hold on. Just to be clear, hold on. So clouds move, I don't know, depending on where you are, 5 to 15 miles an hour. I don't know. Oh my gosh. Right? Now, over 4 hours, that would be somewhere between 20 and 60 miles. Now, do you think that you can see the scale of 20 to 60 miles on that on those images?
I think that there should be at least some.
Okay, so your incredulity is not an argument.
I think there should be at least 1% movement of these clouds, so we don't see any.
Did you analyze it?
Look at it. It's just the orientation.
Just look at it. Well, yeah. These are large-scale structures. Large-scale structures move slowly. Small clouds move quickly. If you're looking at large-scale structures, then of course it's going to not change quickly.
From when I'm like outside, right? I can stare at a cloud, and the shape it'll change shapes in my brain.
Do you know how big the clouds that you see outside are in this image?
Yeah, they're minuscule. They're
like
I understand
1 pixel. You wouldn't.
I understand that, but
you couldn't even see them. I wish that this would like pause so that I could look at a given image.
I think that like if you don't have the intellectual honesty to just admit that this looks more like the orientation of the Earth is just being moved in a digital computer.
I mean, your vibes are just not a particularly compelling argument. I'm sorry.
I came up here to defend the British guy because he couldn't cite examples of NASA putting out fake shit.
Well, the burden of proof is on you to show that it's fake. Just saying look at it is not evidence. Sorry.
You really believe there's a camera out there behind the moon that captured all that in one piece? Are you fucking kidding me?
By the way, and I just want to show you something just because we can look at it. We can just look at it, right? So I've only been looking at this for like 2 seconds. So God, I wish I could pause this.
Wait, look at that green outline, that neon green outline of the moon.
What neon green outline?
If you pause it right there, there's a neon green.
I can't pause it. I'm trying to figure out how to pause it.
Okay, we've also NASA. They have this photo on their website. And it has a neon green
there's 2 photos that I want to compare. So we have,
right there. Go down. Zoom in on the picture below.
So I'll illustrate what I'm trying to get at. So there's like a cloud. See this cloud structure here?
I can't. I mean, I don't really see where your cursor is pointing at.
Here. Now you should be able to. You can see this, right? Okay. So see this big long cloud structure there. and it's down here, right? Big long cloud structure. Now, notice that there's like this little thing at the tip of it, like this little bunch there. See that?
Yeah.
Okay, so
I'm
if you
trying
look,
to track it.
Yeah. So if you look at the beginning, there's a cloud just off to the left of it, right? So right here, there's it'll appear right here in a second. There's a little tiny cloud right off to the left of it, right? Let me, hold on. Just give it a sec. Give it a sec.
I think you're looking too far into it, man.
Oh, so now I'm not supposed to look too closely. Look right
No,
where
you go ahead. No, go ahead. No,
look
I'm
right
not
where
trying
my
to
mouse
stop
is,
you.
right at the beginning.
I don't see what
there's
you're
a,
seeing.
There's
I
a
don't
little
think they
cloud.
get-
There's a little cloud right next to that horn. It's a little tiny one just hanging off the edge, right?
Oh my god.
So it's right there. You can see it in the first few frames. Right there. And then after the moon passes by, that horn doesn't have that cloud there anymore. So like, this is an example of the clouds changing. It's slight change, but it is changing.
On your model, this would be over like probably 8 hours.
This is actually over 4 hours, a little bit less than 4 hours.
Okay. Can you go back to the website though? Because the photo below it, you can see the neon green outline of the so-called photo.
Yeah.
Yeah. Or you zoom in on the moon, on the right corner, the right outline of the moon. Yeah.
Yeah. You mean this? You mean that?
Yes.
That's that's digital compression.
That's. You really
what do you think it is?
I think that it is just digital artifacts.
Yeah, it is a digital artifact. This is a digital photo that was sent a million miles. They have to compress it.
Oh my gosh. So where do you think the photo? What object? What is it? The space station? You think
it was the Discover satellite? No, the Discover satellite is a weather satellite, and it's about 1 million miles away.
What about bubbles in space?
Okay, that's a cool pivot.
Well, no, I came up here to defend the British because he mentioned the bubbles in space. He mentioned bubbles in space, and you didn't even give him an answer.
Did he mention bubbles in space?
Yeah,
I don't remember him mentioning bubbles in space. Maybe I just didn't hear it.
It was in the you can check the VOD. He mentioned that. You didn't say anything about that.
Yeah, I mean, so like maybe I didn't hear it. What about bubbles in space?
Yeah, in these videos, where like they have astronauts outside of the space station, you can see bubbles coming up.
Astronauts outside the space station? Okay, where are these videos?
When they're like tethered to to whatever spacecraft.
Bubbles space station.
Well,
outside.
You're not gonna.
I'm just gonna
I
type
don't know
this
if
into
you'll
YouTube.
I don't know if you'll be able to find it on YouTube because YouTube.
Oh, so then where can I find it?
Well, I know for a fact it's mentioned in the level documentary from Mr.
Your Flat Earth documentary. Gotcha.
Yeah. But the reason why you can't find it when you look it up on YouTube is because the YouTube algorithm has been intentionally tampered with to suppress flat Earth videos and evidence flat Earth proof videos. I swear to God, they did this. It's in a there's a
bubbles in space.
Yeah.
One sec.
Also,
I want to show you something. I just want to find the right clip. Is this the right one? Yeah. Okay.
I mean, there's multiple clips. Like,
okay.
This is a common occurrence.
So, no, this is something else. So this is from the Tiangong space station, by the way. Why does the candle look like that? Why does the flame look like it's just surrounding the? Like, what's going on there?
Well, I believe that there's definitely a 0G effect, but that's because they're in a plane really high up and then they're dipping down, which is causing.
Do you know how long that lasts?
And I know how long they claim it lasts, and I believe they can go longer.
Why do you believe that they can go longer?
Because that's how they're doing these videos.
Oh,
that's how they're doing these live streams.
So you understand that your argument is. Yeah, let's see if we can formalize this. Well, no, of course we can't because it's not valid. But your argument is. They are on the explanation for why the candles look that way is because there's a 0G effect.
Yeah.
We know that the 0G effect must be able to last longer than say 45 seconds because we know that they must be on a 0G scenario.
Well,
you're making a circular argument. You're saying we can explain this fact because they're on a 0G effect. And we can know that they're on a 0G flight for longer than 45 seconds because of this video.
Let me give you
It could just be that they're in space.
Let me give you a counter question, okay? If they're really in space, why do they need to wear harnesses in these videos? Why have we seen their harnesses clip in and out of the view on these live streams before?
Yeah, so I've heard that claim. They're always easily explained via like, look, like, there's not a harness or somebody just poked somebody. There's like the one of like the guy that looks like he's like grabbing him, but he's just touching him.
So it doesn't exist. We're
wrong. Yeah, you are just wrong. Yeah.
How do you know? Are you there? Are you up there with them?
I mean, it's pretty easy to see what's going on. And like, if it were the case, look, do you know what fascism is?
Yeah.
Okay. One of the things that fascists do, this like in the playbook, is they simultaneously believe that the enemy is incredibly strong, so they must be defeated, but also that they're incredibly weak and degenerate, so we're so much stronger than them, so we can defeat them, right? It's a weird like internal contradiction that fascists hold. That like you know, if you're a Nazi, you both simultaneously think that the Jews are like so strong that they can control everything, but they're also like vermin, and they should be stamped out by the righteous Aryans, right? Like that's a fascist thing.
Is this not a pivot?
No, I'm making a point. So this is a fascist thing. Now, what I've noticed is that this is a similar thing happens for flat earthers. Namely, on the one hand, NASA is this incredibly powerful organization that's capable of hiding everything from everybody for decades, and every time, every single space agency, it's all this, like, they're so powerful. And on the other hand, they
have evidence for those as well.
And on the other hand, they just like fail to, fix their green screen because they're incompetent.
Well,
so which one is it? Are they so ultimately powerful and they can control everything, or are they incompetent? Which one is it?
I think that the henchmen they have working for them at NASA, like they're not very smart. They're just put there for the numbers.
Yeah, NASA people definitely don't have to be smart to get a job there.
Well, the reason why I say that is because one time they were caught using a blue screen, but then they tried to play it off like they use them all the time for their experiments. Do you know what a blue screen is?
Well, yeah, I mean, we usually call them green screens nowadays.
Well, this was a blue screen, and they were caught red-handed using it, and then they later tried
red-handed using it.
NASA.
Okay,
NASA.
When?
I have it again. I have it in the documentary.
Recently?
I can find the time. Yeah, well, I think it was like a couple decades ago, like probably 10 or 20 years ago, but they were still caught red-handed using it. Now I can show you
using it. So look, like in any media production. Like if you're trying to
media production.
Yeah, please let me finish my sentence. Like if you're trying to do like a PR thing, like when CNN is like they're recording like their morning news or whatever, they have a green screen behind them so that they can show the city. So like often you'll have like announcers talking, and they're obviously on the ground and they're not claiming to be in space, and then they'll have like something going on behind them, just to like illustrate, whatever it is they're talking about.
Yeah,
like, of course they're going to have those kinds of media productions because NASA is a government organization. They have to sell their work. They have to sell their work to the people. So of course they're going to do that. Now the question is did they actually use green screens to produce everything that we see that comes from NASA? And the answer is like obviously no.
This is what I found it. I have my camera on.
Okay.
So he should not be falling like this if he's.
Is that person? No, they're not naked. Okay.
Yeah.
Just checking.
Well, here's the part. It's coming up. This is how they do their 0G live streams from these planes that they.
How long do the planes stay in the 0G environment? How long can they?
Probably at least a couple minutes.
So you know that would mean falling for a couple minutes, right?
Yeah, they go up extremely high.
How high do they go?
Probably like 100,000 feet up.
100,000 feet up. Can you give me an example of a plane that can fly that high?
They're planes. Look, there it is, right there. You see it?
I don't know what I'm looking at.
Look at the blue screen right here.
The checkerboard?
That's a blue screen. And look at the person in there. That's the exact same clip right here.
I don't think it's the exact same clip.
No, look.
I'm looking closely. Why is his hand in a different orientation if it's the same clip?
It's coming up. But as you can see, this is the exact same person. They have the same hairline, the same face, the same shirt. It's the same person.
Well, they don't look like they're the same person, but sure, maybe they are.
Here's a diagram of how these blue screens work.
Wait, why? What? Hold on. So to be clear, if you have two different colors, You can't have a blue, like a green screen effect, right?
Let me turn my brightness up so you can see better.
You know that, right?
Or what do I know?
That if you have two different colors, you can't green screen it away.
Well, they're using a blue screen, not a green screen.
A blue screen is just what a green screen used to be called because they used to use blue screens instead of green screens. But if you have checkerboard on top of the blue, the checkerboard won't disappear.
All I'm saying is that.
Do you know how green screening works? It's called chroma keying. Do you know how that works? Apparently, that's a cargo net.
You think this is a cargo net? Is that what they told you? Is that what they told you?
Apparently, that's what it is. It's definitely not a blue screen.
Well, listen, Blitz. A fraud can tell you any explanation. It doesn't mean it's true.
How do you know it's a blue screen?
Okay. All right. I guess we're gonna do this.
Do it. Somebody said it was a cargo net, which it could be.
Why don't you bring that person up and we can?
I don't know who it was.
Well, whoever it is, they're a fraud.
Okay.
But, let me just.
So do you want to know what a blue screen looks like? It's just a blue screen. There's no checkerboard on it. The blue screen method was developed in the 1930s at RKO Radio Pictures. They used an early version of the traveling mat to create wipers, blah, 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 blah. The name chroma key was RCA's trade name for the process. For decades, traveling mat shots had to be done locked down so that neither the matted subject nor the background could shift their camera perspective at all. Meteorologists on television often use a field monitor to the side of the screen to see where they're putting their hands. Some films make heavy use of... Okay, that's fine. So, apparently, I don't actually know when they switched to green screens. But I don't know why it's not giving me any years.
Our point is that they should just be transparent and not use this kind of...
And my point is that that's not a chroma keying background.
Okay, well, we've seen this person in this angle with this ball in his hand. We've seen that before, but there was behind him. It was the actual space station. It wasn't this blue screen. That's what we're saying.
Okay, so where did this blue screen with white check mark or checkerboard on it? Where did that come from?
It came from this live stream where they accidentally had it up without turning it on. This is from NASA. Here, I'll show you.
Okay, let's go see if we can find the actual video.
Here,
rather than just like something from this documentary of yours.
Right, like, so they're obviously unprepared. They're wheeling someone in a wheelchair away, but in the background they have this clip left up there with the blue screen. And
Sorry,
the guy,
what color is that thing on his shirt? The NASA logo?
It is
looks blue, doesn't it?
Wait. I'm gonna show you the side by side.
In fact,
look. Here it is.
In fact, do you know what color the NASA logo is?
Yeah, it's a snake's tongue.
Here, I'm gonna show you something really quick. This is the NASA logo, right? This is what he's wearing on his shirt.
Yeah.
Now, this looks awfully close to the blue color in the background. So if they were chroma keying it out, why can't we see through his chest?
I just want to show you guys this. NASA's logo is a snake's tongue.
Yep, definitely, it's a snake's tongue. Now, why can't we see through his chest if they're chroma keying out blue?
Well,
you don't know.
You don't know for a fact that it even is.
His shirt is blue. Look, why isn't his shirt disappearing?
They could have used a green screen in this clip. Like they might when they're wearing blue.
Are they using a blue screen or a green screen?
They're using everything. They're using harnesses.
Evidence. Give me evidence.
Okay, I will. But do you want the evidence of them using harnesses as well? We have all this. We've done it all. We've done all the homework for you guys.
I'm sure you have. And why is it that they've all been debunked, every single one of them?
They haven't.
So
look,
wait, by the way, hold on, go back.
Here's what it looks like. Here's what it's not the NASA logo.
It's blue.
Okay, yeah.
So
it's
why
blue,
can't we see through it? If they're chroma keying out the blue background, why can't we see through it?
This is more cyan than blue, but
it would still be chroma keyed out.
It's clearly the same person.
Why can't we see through his chest?
Because they're probably using a green screen after they got caught using the blue screen.
Wait. So the screen behind them is not what they're chroma keying out?
They got caught for it. Look, they got caught for it here.
How do you know that has anything to do with what we're seeing on the right?
because when they're showing us like the astronauts playing with balls in zero G environments, what we're seeing is the back of this so-called space station. We're not seeing this blue screen.
Okay, if it's a blue screen, then we should be seeing through his chest.
Well, what I'm saying is this this was before they got caught using it.
Right. But if the thing on the right is the same thing, if it's the same recording, they just blue screened out the background, then we should see through his chest.
I think this is a future recording. This is a past recording. They're using a green screen in this image. That's
so
evident.
Wait a minute. So then this is not evidence that the thing on the right was green screened, or blue screened, for that matter.
Why are they having these astronauts play with balls in zero G environments with a blue screen behind it?
I don't think it's in zero G on the left.
They got caught using it.
What do you mean they got caught?
I mean, in this live stream, in this clip, nobody knew. Let me unpause. Sorry. In this clip, nobody knew prior to this clip that they were using this kind of technology.
How do you know that nobody knew?
Because it wasn't public knowledge. After they were called out by it from people, from flat earthers, they changed it, and then they started.
So this is the narrative. The narrative is that nobody had ever seen this blue. By the way, you still haven't explained why there's a grid there. I suspect what's happening is that they're using it as a measuring tape, basically, so that they can figure out how far things go for. How far things move and how quickly they move.
Yeah. Here's a 3D animation explaining.
Oh, why are you showing me a NASA animation? It's so fake. Why don't you show me the real thing?
Because they tried putting out these animations later to try and play it off this is how they do their experiments. Look, now they have it in the background like it's nothing.
So those grid markers could be used to measure distances.
Okay.
Why do they have footage of that guy standing in front of the green screen, or the blue screen, not the blue screen with the grid, not this one, the one that you were just looking at?
Because that comes later on after they were caught. They try to play it off.
Why do they have this footage?
Because after they were called out, they tried to play it off like this is just.
Alternatively, they were just telling the truth, and it wasn't some big old conspiracy.
Look here's an example. Here's one with the blue screen and one without.
That sounds like wait, how are you getting rid of the white?
I don't know how they do it.
Is that a real person?
Yeah, this comes from.
Can you bring it up closer? It just looks like a bad render. Okay, yeah, it was just because it was far away.
A broadcast.
So how are they getting rid of the white marks?
I don't know, man. I don't know how they do this stuff.
Okay, because you can't get rid of those with chroma keying without getting rid of his hair too. So I think that you should probably look into how chroma keying works.
I think you should look into more the videos that we have of their shit glitching out. Like, look, he's touching his harness. Look at this. He's flipping over. The guy right beside him, he's grabbing his harness.
He just reaches for the microphone, which he thought was there, and he misses. Man, you're so gullible.
You can't be this naive, Blitz.
Okay, so what do you make of the fact that like we have video from the moon from 1972, or we have video that's allegedly from the moon, rather. It's from 1972. So this is before like Photoshop, and this is before AI and all of this stuff, right? We have video that's allegedly from the moon that is incompatible with the laws of physics on Earth.
It's fake.
How is it faked?
We've debunked the moon landing in so many different ways.
How is it faked?
It was filmed in a studio.
Okay. How did they get a vacuum chamber the size of several football fields and also reduce the gravity inside the vacuum chamber?
They didn't reduce the gravity. What you're talking about?
Why does the dust fall at 1/6 the rate that it would on Earth?
I knew that was what you were going to say. The reason why it falls like that is because they slowed the video down, that's why the effect comes away.
Slowing the video down doesn't account for why it's in a vacuum chamber, right? We also know that it must be in an enormous vacuum chamber.
The dust falls eventually in those videos.
The important point is that it falls with no aerodynamic resistance.
But if it's in a zero-G environment, shouldn't it not fall at all?
It's not. The moon isn't zero-G. The moon is 1/6 gravity.
You're right. That's my. Sorry. What I meant to say is that the way that they make it look like that is just by slowing the video down.
Slowing the video down won't make the acceleration go from non-zero to zero.
That's a cope, and you know it. And we
It's
can pull up the
literally not a
clip.
cope. Slowing the video down will only scale things. It won't make something go from non-zero to 0.
We can pull up that clip if you want to. But the
The
other
point
ways
is
we
that
know
there's no aerodynamic drag, so it must have been done in a giant vacuum chamber.
Blitz. I need you to like really critically think about the moon landing for a second. Do you actually think?
Cool pivot, but sure.
Do you actually think that we spent hundreds of millions of dollars to plant a fucking flag when we could have just easily faked it on Earth in a studio for much cheaper?
It's not easy to fake it. In fact, the Soviet Union congratulated the US on it, even though they would have been the people that would be most likely to want to call the US out if there was even a scintilla of fakery or of trickery, right?
Well, I mean,
why would the Soviet Union join us on the lie if they were our enemies?
Because they thought they looked believable for the time, but that was before the internet. But that was before people came together to truly
before brain
scrutinize.
rot. You're right. You don't think that they scrutinized it more than you have?
No, not at all. That was before the internet. That was before you could easily access files.
They had telescopes and radios that were analyzing it while it was going.
Well, yeah, I mean, the rocket obviously went up, but people saw that. That doesn't mean that they went hundreds of thousands of miles to the fucking moon.
1 sec. So there's unfortunately, we can just pull this up. There is like a whole slew. This is lovely. I love this. I love that this exists. Third-party evidence for the moon landings. Independent evidence. So each of the countries mentioned in this section has its own space program, builds its own space probes, which are launched on their own vehicles, and has its own deep space communication network. So we can just look at other photos taken by other organizations. But in particular, I want to look for.
I have a question.
Yeah, you have a question?
Not about it, but do you believe India went to the moon?
Yeah, obviously.
Oh, obviously. So
yeah.
Okay. Well, let's just pull up the footage of that while you get that up.
Oh, I don't think that we have video footage of it landing.
Well, they do, and you can tell it's fake as fuck.
Oh no! You have there's a telemetry animation, but that's not footage. Nobody ever claimed that was footage.
Just let me pull it up.
Oh, you don't know that? You didn't know that that was a telemetry animation?
It's been a while. It's been 2 years since they faked it, so I got to remember what they did with them.
Why couldn't the Indians go to the moon?
No one can go to the moon.
Oh,
It's not like a racial thing. Like they're too stupid to get to. No, it's just no one can go there. It's not real. It's a fantasy.
I mean, that's cool, but unless you have evidence of that, then I don't know why I would believe it.
I do. I have this great video from 2 years ago from Mr. Dubé.
Oh, you know Eric Dubé is like a Nazi, right?
I don't know anything about that, and I don't want to know. All I want to know is.
Well, he is a Nazi.
Okay, all I want to know is how he Yeah, this is the footage. This is the official footage.
Right, that's not at the landing. That's at the orbiter. Yeah.
No, this is them. This is them when they're approaching the surface, supposedly. This is official footage.
Hold on, I don't think that is. Hold on, let me pull it up.
It's from the ISRO. This is.
That's from the orbiter, right?
This is when they supposedly went on the surface.
We don't have. Okay, so there's. I think I know what you're referring to. Are you referring to this?
Yes.
Yes, that's a telemetry animation. Nobody ever claimed that.
That's fine.
Nobody ever
that's
claimed
fine.
that. Nobody ever claimed that this was footage.
That's fine, but yeah, because it's fake as fuck, right? But
yeah, it's an animation. It's intended to display information. It's not intended to be a video.
Blitz, don't run. This is them when they're claiming to
this is an animation of what's happening based off of the telemetry.
Blitz, I'm talking about what's on my screen.
Okay,
I'm showing.
I'm looking for that particular footage.
Then if you want to pull up the exact clip, you're gonna have to go to Mr. Dubé's channel.
No, I'm sure that this is available elsewhere.
Okay.
I don't have to patronize a Nazi in order to see the Indian landing.
Blitz, can you just stop running? Because I have it pulled up on my screen. This is what we're looking at.
I know, and it's very small.
It's the rover. This is the.
Okay, so we want the rover. Okay, let's see if we can find the rover. Here we go. Okay, here we go. Is this what you're referring to? So we have, here we go. So we have this, right?
Yeah, that's what I wasn't talking about the telemetry animation. I've been talking about
Okay,
this the
so
whole
is this
time.
what you're talking about?
Yes.
Okay, this is just video from the orbiter. This is not from the rover.
No, but then the rover, the rover's in the same. It's from
It's
the
from-
ISRO. It's from the same source. Yes.
Okay, what's the issue here?
Do you actually believe that?
Yeah, what's the issue?
Do you believe it?
What's the issue?
The issue is that this is the only clip we have of it.
Okay.
And that could easily be faked in the studio.
Why should I not believe it?
Because
what's the evidence?
Because all it would
That's fake.
take is all it would take is for them to point the camera at the Earth from the moon with the rover in it. Get
Wait, why
multiple
should I
wide
believe that
angle
this
shots.
is fake? Why should I believe that this is fake?
Because this could easily be faked in the studio.
Lots of
It
things
isn't-
can be faked. That doesn't mean lots of things are fake, right?
Don't you agree that they could just easily point their camera at the Earth if they were really on the moon?
Lots of things can be faked. It doesn't mean they are fake.
That's not what I asked you. I asked.
They
don't you
could.
think-
They didn't. How does that make
why
that,
did,
that
so
doesn't
why
make
did
this
so
fake?
so why didn't they?
Because they weren't concerned with flat earthers.
Oh, that's a cope, dude. If India really went there, if they were truly on the moon, you could get the most magnificent, beautiful shots of Earth on that surface with the lunar lander.
And you would call them
proof-
fake anyway.
Well, we would scrutinize the evidence and see
You
if
would
it's
just call
real
them
or not.
fake.
No, not
That's what-
necessarily.
look, I can go find you plenty of lovely photos from the moon or from near the moon of the Earth, and you'll be like, that's fake, that's fake, that's fake, that's fake.
No, Blitz, you're
Okay.
you're being disingenuous. You're not being
I'm
honest.
gonna make a prediction here. One sec.
Blitz.
One sec. I'm gonna make a prediction here.
Your argument. You brought up.
I'm gonna write. Actually, you know what I'm gonna do? One sec. I'm gonna write something down.
Blitz. Your argument was that if there's all these different space agencies.
Here, I wrote something down. This is going to be. I'm going to predict that this is your response to what I'm about to show you. Okay.
Oh my gosh, this is so performative.
Well, I shouldn't be able to predict or read your mind if you're genuinely examining the data. Now, what's the deal with this photo? Lovely photo from on the way to the moon, right? So, is this real?
I don't believe it's real.
Why not?
Well, because I am a flat earther. I can't believe this is real. Now,
Why do you not think it's real?
Well, I wasn't
rather
there.
than doing confirmation bias, why do you think that it's what is it? What do you think that it is? That's fake. Of course you're predictable. Anything, any image I show you, any photo I show you, you're obligated to believe it's fake because your ideology that the Earth is flat comes before the evidence for you.
You're being so disingenuous here. And the reason why I brought up the Indian space station is because you said that if there's all these different space agencies, the chances of Earth actually being flat and all these pictures being fake of the Earth from the moon, the chances of that
That
being
wasn't why I brought
fake,
up the other space agencies. Actually, I can
Well,
go
you
over
said-
that if you want. I can
Blitz,
tell you why I brought
Blitz,
it up
Blitz,
if you want.
you said that it would be it's much more likely that it's real if all these different space
That's
agencies are
literally not what I said. What I was citing the other space agencies providing evidence that the United States landed on the moon 6 times. I was providing evidence of that there are other competing space agencies who are not geopolitical allies, like the Chinese Space Agency, the USSR Space Agency. These are organizations that already agreed that we landed on the moon.
That's fine. That's fine.
It is in their geopolitical interest to show that the United States was fraudulent, and yet they don't.
That's fine.
So why don't they? Why do they do the opposite of what is aligned with their geopolitical interests?
Because I think if they were to shatter the whole idea that we've been to the moon, that we can leave this world as domain, then it doesn't bode well for their country either. Because as you can see, these other countries
So
like
they're
India,
in on the conspiracy, right?
well, they want their country to look good in front of the world and say we went to the moon, we can go to space, we got all this advanced technology. They don't want to just come out and admit that no, it's all fake. None of us can do that. It's not real. They don't want to admit that.
So they're in on the conspiracy, right?
Of course they are.
Okay.
And this
Okay,
is
of
why I
course they
showed
are.
you this video. This is why I showed you this video from the ISRO. All they would have to do, and by the way, keep in mind, these are the only 2 clips we have of the actual so-called landing of the moon from India. This is it. This is it. These all they would have to do is whoever was on that craft as soon
Nobody
as
was on it.
No one was on it.
It was unmanned.
Really?
Yeah.
So okay, that doesn't
How do you
change the
not
fact
know
that
this?
that
Have you
doesn't
not even
change
looked into this?
that doesn't change the fact that all they would have to do is take one of their cameras and point it at the Earth from the moon. They didn't do that. These are the only 2 clips we have.
Yeah. Why would they do that? Like they're not appealing to flat earthers. That's not their job.
They should do it because they shouldn't India want us to really believe that they went to the moon?
So by the way, there's a galaxy. There's an entire gallery that they released. We can go find the. We can go find the photos.
Like they can take some.
We can go find the photos, and
yeah,
I'm
go
sure
ahead.
that there's plenty.
My point is that they could take some.
Here's an image gallery. Well, these are from Earth, right? Here's images.
So is there a single one from the moon looking at Earth?
I have no idea. Have you looked into this? Because it doesn't sound like you have. You didn't even know that it was unmanned.
Okay, but my point is that even if it was unmanned, they could still attach a photo to the rocket and get some photos of Earth. They didn't do that.
But you haven't looked into this. How can you say that they didn't do it if you haven't looked into it?
Blitz, you just pulled up the fucking gallery. There's no photos of Earth.
That's not the full gallery. That was like 8 photos. That was like a sample of the gallery.
If you want to pull up the full gallery, and if you're right, then I'll admit I'm wrong. But
I need to find the full gallery first.
I bet you won't do it.
I'm just seeing a whole bunch of photos from individual places. I want to see the actual gallery.
And by the way, me admitting I'm wrong is me admitting I'm wrong about there not being a photo of the Earth from the moon. That supposedly, right? I'm not admitting that.
Look, I don't know why they would take a photo of the Earth when their goal was to do science on the moon.
Because it would be a glorious photo. It would be beautiful, magnificent.
That wasn't their goal. Oh, by the way, also apparently there are way more videos, more than just what you showed us. They're just not very interesting videos. I'm looking through them now to see if we can find it. Yeah, so here's another video, by the way. Why are you lying to me about those 2 being the only videos?
Let's see.
Here's another one. It's not the same video that you just showed me.
It's the same kind of shit though, right? It's just
it's from the same camera. It's a different video though.
Yeah, but it's just a rover on a rocky surface.
So why did you lie to me about there's only being 2 videos?
I didn't lie. It's not that I lied. I didn't know that there was.
Okay, so you admit that you're ignorant of this stuff.
Blitz, that other video, it still doesn't show shit. It's just a rover on a rocky surface.
What this demonstrates is that you haven't looked into this at all. You've watched a documentary, maybe by Eric Dubé, and then you just believed it, I guess. That's the entire ethos that you have here.
No, what we're saying is that it's so easy. It would be so easy for them to be vindicated and prove to us that it's actually.
They're not looking to appeal to flat earthers. You wouldn't believe them anyway.
Oh my.
By the way, here's another video from the orbiter.
Oh my gosh. Man, you believe anything a fraud in a lab coat tells you. I need to show you something.
Is this another video? No, that's just
those
are just pictures.
That looks like an animation.
These are just pictures. Here's another video. This is viewed from the moon during lunar insertion. This might be the first one that you showed that we looked at.
Maybe. But check this out.
So look, I mean, you would just call everything that I show you fake. Which is really a shame, because we can just do private launches and we can see the curvature of the Earth from them.
Blitz, this is what the stars at nighttime when there's no light pollution, this is what they looks like.
With long exposures, yeah.
The thing is,
yeah, so I've actually been in such a place that doesn't look like that. That's what it looks like with long exposure.
Okay, but the point is, we never see this in any of these space live streams.
We also never see that in real life.
Videos. You can when there's no light pollution.
I've been on top of a mountain in pitch black darkness, specifically for the purpose of stargazing in Hawaii, where there's basically no light pollution, and it doesn't look like that. That's what it looks like with long exposure. This is a camera effect.
So which one is real? Which of these photos looks real? Are any of these real, or are they all fake?
I don't know what you're... long exposure doesn't mean fake.
Okay.
Long exposure is just a specific kind of thing, and you can't take a video with long exposure.
The point I'm making is that The point I'm making is that you never see this in any of these live streams from space.
That's because
from
those are
NASA.
long exposures, and that one's a panoramic, by the way.
It doesn't matter.
The cameras don't work that way.
No, but the thing is, what we see in these live streams is it's basically pitch black every time. But here's the thing: if the real
take your next time you can take your video camera, take a video camera, and then point it at the sky while the lights are on inside, and then see if you can see any stars.
Look, the thing is, from their live streams, it is always pitch black.
Yeah,
there's no
that's
stars.
not a real. That's not a raw photo. That is a long exposure, and it looks like it's been color corrected too. Because that's not what the sky doesn't look blue at night.
But it sure as hell ain't pitch black. It ain't pitch. And if they're really up there,
it definitely is.
When they're up there, the lights from Earth are not obstructing. It's not causing light pollution when they're up there.
The lights inside are inside the capsule.
That's fine, but surely they can.
Wait, hold on.
Go to it. Man,
1 sec. Let me show you something.
you are so disingenuous today.
I want to show you something.
You're not normally like this, man.
Here, do you want to see something neat?
What? What's so neat?
See the stars? This is from the Artemis.
Yeah, there's a couple there.
Yeah, so you can see the stars. It's not pitch black.
But the thing is, if every 12 hours they should have the perfect opportunity to take a photo of the night sky without any light pollution from Earth and
Every
get
12 hours? Do you think that they're not on Earth? You know that they're not spinning at the same rate as the Earth, right?
That's fine, but surely there's times when the Earth is obstructing the sunlight where they should be able to get a perfect, beautiful shot.
By the way, this photo is the Earth obstructing the sunlight. You can see the Terminator line here.
Yes, you can.
So this is an example of the Earth, and this is what you see. You see stars, and actually, you see plenty of stars. All things
that
considered.
that looks like Africa there. So if someone's in a rocket,
this is like you see like plenty of stars, by the way.
Not nearly as much as you can see from Earth when there's no light pollution, which is very odd. That should not be the case at
you
all.
actually can see plenty, but the point is this is a long exposure photo, but it couldn't. They have to turn down the what is it called? ISRO, not ISRO. There's a camera setting, so that basically the Earth wouldn't wash it out, because even despite the Earth being pointed away from the sun, this is still super, super bright compared to the distant stars.
Here's the point we're making, right? And you can see like the amount of stars.
I'm sorry, it's ISO, not ISRO.
The amount of stars in that image of that you have on your screen. Can you go back to it?
Sure.
It's what you would see like right here. You can see a few, but not nearly as much as you can see here from Earth.
Those are long exposure photos.
But this has never been seen on any.
That's because that's not how the world actually looks. That's not how space actually looks. That's long exposure.
You should at least be able to see like the halfway point between this photo and this photo from space when there's no light.
Why? Is it just your intuition? Is your intuition and you get wrong about it? Sorry, that didn't make any sense. Is it just because your intuition says so and therefore it must be true?
Yeah, well.
I'm sorry, your intuition's wrong about this. Clearly, it's wrong about a lot of stuff.
I think that you're
it's just vibes at this point.
I think that you just believe what these frauds are telling you because
I think that I believe things that have sufficient evidence for them.
Blitz, I gotta ask you this: Is there? Let's say you found out the Earth was flat by doing whatever experiment, right? You came to the conclusion it was flat.
Yep.
Would you have the intellectual honesty to admit to your audience that it's flat, or are you too audience captured?
Of course.
Are you sure you're not too audience captured?
Yeah, I would become the biggest flatter. I would be so proud of it because I would win a Nobel Prize.
What about all the donations that you would stop getting?
I would get so many more You know the Nobel Prize, you win $1 million, right?
Okay.
I would rather get $1 million than get like $100, maybe.
Well, all I'm saying is right now, I think that you are audience captured because the explanation you gave, it's not sufficient, man.
Well, it's not sufficient for you because you have some extreme cognitive biases that are preventing you from accepting what is obviously the case.
I'm using common sense and coming to the conclusion that if you're up there, if you're in space, you're not the light pollution of Earth is not affecting you in any way. You should be up there closer to the stars, which means they should be brighter, which means that you should be able to see more than them. That's
okay. So you realize that you're not any substantially closer to the stars when you're 1,000 miles away from Earth than you are when you're on the Earth.
Sure,
right?
on that model, sure, not substantially
Okay.
closer.
And you realize
but,
that the photo that you're showing on the right is is long exposure.
So
which
it's,
is not
it's
how
fake,
eyes
guys.
work. Well, it's not fake. It's just a way that cameras can function for photographs, but you can't get video that looks like that, and you can't make your eyes do that either, because your eyes don't have a long exposure setting.
Sure, I guess they can't get a video of that, but they can take a photo from their space
They could do a
station.
long exposure photo, I suppose. Yeah, but of course they would have to mount.
But they've never done that.
Tripod.
Don't you think it's suspicious?
Actually, not true.
They've never done that.
Actually, you know what's funny? They have done that. They're called space telescopes.
Let's see.
They're called space telescopes. We have several.
Let's see if it's because it's very odd that you can get more impressive photos of the night sky from Earth than.
Hold on. Let's go see if we can find some raw Hubble data.
Isn't Hubble on Earth?
No. It's orbiting.
Okay.
Here you go. I just want to make sure that this is legit. Yeah, okay. Here's a raw data image.
Okay. Let's see it. Where's that?
That's the Horsehead Nebula.
Why can't we see this from Earth?
You can.
From where? What?
You can. I mean, I can go pull up pictures of Horsehead Nebula from Earth if you want.
You should get it side by side.
Yeah. Okay. Well. Yeah. Sure. I just want to make sure that I find some that are actually like.
Why is it in black and white?
Because telescopes use filters. They like filter out all but the red light. They filter out all but the green light of certain wavelength. So they just because it's a scientific instrument.
When was this photo taken?
That one's old. Let me see if I can find when it was taken.
So before the internet.
Well, I don't know if it was before the internet. The internet's pretty old. Looks like it was in 1995.
Yeah, so before the age of information.
Yeah, sure.
All right. That is a little bit problematic.
It's not the Horsehead Nebula. It's the Pillars of Creation within the Eagle Nebula. My bad.
That's just a little bit problematic, but
why?
Well, it's before people, before we could start sharing information at instantaneous rates.
Yeah, it's also before AI and it's before Photoshop was widely used.
Yeah, I mean that obviously bolsters its case. That's not a definitive proof.
Okay, let me show you a picture.
Let's see side by side though to see if it.
I want to see. I just want to see an amateur, like an amateur thing, because otherwise you'll just say that it's probably fake. So this is. I think that this is a color corrected photo. No, that's the Hubble. I want to see if there's a. I want to zoom in. God, what is this website? I mean, I can show you other pictures of it, but they're going to be like here. These are like other pictures. This is another one.
So I'm
trying to find amateur ones for you. So
wait,
then you
hold
can't
on. The
call it
reason
fake.
you gave for it having me black and white was they're using filters.
Yeah,
but
yeah.
in that photo,
So this is composited with several. This will be composited with several different filters. So so the image that I showed you was one of three. Where'd it go? This is one of three, right? So there's three different filters. Or no, I'm sorry. This is just contrasted. This is just contrast changed.
But you said that we've been able to take a photo of this nebula from Earth before.
I'm absolutely sure. I can go. I can find you that. It's just a matter of finding which telescope did it.
So in other words, there is no proof that picture comes from space on Hubble. Other than they say it comes from Hubble. It could just be a picture from Earth that they're claiming.
Okay, so see, that's exactly my point. I knew that you would say, well, like, so you asked me okay, so here's what would have happened. If I found you, if I said, no, there are no photos of this from Earth, you would say, well, then it's fake. How can you prove that it's real? And if I said that there are photos from Earth, you would say, well, how do you know it's not taken? How do you know that's not a photo taken from Earth? Right? Like, there's no way, there's nothing that I could have given you that would make you think that it's real.
Well, you originally
which is confirmation bias, by the way.
You originally brought this up because you said that we've seen these beautiful pictures of space.
This is taken from a different telescope, by the way. So here we have it in visible light. Here we have it in infrared.
Yeah, but it can be taken from Earth as well. You just
Probably,
submitted that.
yeah. That one
You,
wasn't.
no, not
That was
probably. No, not probably. You
Well,
admitted
I
that.
haven't found any. This one's
You
taken
said-
from the Hubble.
You said definitely. You said definitely. We have a picture.
I haven't found one yet. So like I would believe it if we could find it. I just haven't found it yet.
Oh. This is backtracking, guys.
So let's see, amateur telescope. I'm sure that somebody has it. It probably just won't look very good. Okay, so this person says Hubble versus me. So Hubble's on the left, and then their amateur telescope is on the right.
Yeah. So in other words, this has nothing to do with. This is not a proof of space. This is not a proof of.
Well,
of
I knew that you would just reject it,
space.
right? Because like you're just gonna like, regardless of the answer that I give you, whether or not we have images of this thing from Earth or not, it's going to be the case that you'll reject it for one reason or another. Which is how I know that you're engaging in confirmation bias rather than actually trying to be objective here.
Because I asked.
No. Yes, of course you are.
Blitz, before I asked you if it was from Earth, like I was accepting the possibility that you were going to say that there are no telescopes that have captured this from
And if
Earth.
I had said that, what would you have said?
Well, I would have, obviously, I would have to scrutinize it more, and like that's what anyone should do. But the fact that there are is picture, we can do. We
I
can
would
get this
actually be interested to see if you could find any photos that are that high resolution from Earth.
But it can be done though, and you can take composite.
No, it cannot be done. Not that high resolution. You can find images of the.
But you just admitted. You just admitted we can composite multiple photos and put them together to create.
This is what it looks like from Earth, by the way. Apparently, this is taken from a guy just outside of Los Angeles. This is what it looks like from Earth. Right.
Yeah, so you could do that, but if you
Look how low
if you got a
resolution it
bigger,
is.
if that's probably a fucking homemade telescope. That's probably like a telescope for one person.
Yes, telescopes have one eyepiece, right? I mean, there are also digital telescopes, of course.
No, with a bigger telescope from Earth, you could get that same angle, same image. It's not proof of anything.
Yeah, and what you won't see? You won't see this. I think that this is from James Webb, so this is an updated image from James Webb. You won't see this.
Which is on Earth, right?
No, also in space. You won't see this. You will never find any telescope on Earth that will produce an image this clear of the pillars of creation.
If with a big enough telescope on Earth, you could absolutely do that.
No, there's too much distortion from the atmosphere.
If you went some of these telescopes on Earth, they're purposely made in places where there is.
I know there's still too much atmosphere. Look, let's see if there's a Keck telescope image of pillars of creation. Let's see. Because Keck is on that's the telescope that I've been to, or that I was very close to when I was, which is supposed to be super, super dark. Super, that's James Webb. Super, super clear. That's James Webb.
This isn't proof of any model though.
What it is proof of is that you can't get an image like that in that resolution from the ground.
That's a claim.
Okay, well, do you want to provide something that's that good?
Well, what I want these so-called astronauts. I want them when the sunlight is not in their way, like when they're covered by the Earth is obstructing the sunlight. I want them to show us beautiful photos of the night sky with their iPhones, with whatever
iPhones
smartphone.
don't take good photos of the night sky.
They can if you change the settings to the right settings, you can. But the point is, I want these astronauts. If they're really up there, they sure as hell got their.
You mean like in the ISS?
Wherever they are, in any kind of spaceship, if they're really up there, all it would take is for them every 12 hours, like when the Earth is supposedly rotating around the sun on that model.
Why do you keep saying every 12 hours? Do you not know that they're not on the Earth rotating with the Earth? Their orbit is different.
Yes, but I'm saying when on that model, when this
it wouldn't
Earth
be every 12 hours.
Whatever time it is. Surely there's a time when the Earth is obstructing the sunlight. They can take a beautiful photo of the night sky.
Here, do you want an image from Don Petit? Is that how you say it? Petit? Here's an image from Don Petit.
Oh, the same guy who claimed that we can't go back to the moon.
Look at all of those stars, by the way. Look at all those stars.
Do you know that guy claimed we can't go back to the moon because we destroy the technology?
I know that that's what flat earthers like to say. He said.
That's a quote.
It's a cool pivot though. Here's an image from Don Petit, and look at all those stars.
Yeah.
So that's exactly what you asked for, and now you're not going to change your mind because I know that you accused me of being audience captured, but I think that you're, worldview captured, right? If you change your worldview, you will all of a sudden lose your friends, lose your community, and that would be devastating.
It would not be that hard for them to just be able to just prove that they're
Here's
really
another,
up there.
by the way.
It's not that hard.
This is exactly what you asked for, by the way. This is exactly what you asked for.
I don't know enough about these specific images.
I fucking knew it. I fucking knew it. Do you think that this photo's real?
I don't know. I look, Blitz. I go into these conversations and debates with the expectation that I could always be proven wrong, and I could be convinced that it's actually a sphere.
And
it's
yeah,
actually
with this photograph, which shows an obvious curvature and by the way, this in this case, it's almost certainly barrel distortion, but we see exactly what you asked for as far as the long exposure photo from space, seeing plenty of stars like you can see on Earth. This is exactly what you asked for, and now you're like, I don't know. It's dishonesty.
I think you've been dishonest.
I have pulled up so many pieces of evidence.
I'm not saying that you've been dishonest the whole time, but when certain stuff you definitely haven't been as honest as you could be. And this is why I say your audience captured, because no matter what evidence a flat earther gives you, it's not enough for you.
So then what's your excuse?
Well, the first thing I would say is this picture, the way that the lights are distorted from Earth, supposedly, it looks like this.
It's long exposure.
Okay. Well, it looks like whatever spacecraft this is on is going extremely fast.
This is the ISS goes extremely fast. It orbits once every 90 minutes.
Okay. That is problematic.
Why is that problematic?
Because if it's really going that fast, then the chances of it hitting another satellite up there are pretty high, but that's never happened.
Space is big. Space is big. The orbits are stable. As long as nothing is crossing the orbits, they won't collide. Space is far bigger than you think. They can track these things. This is a rescue device that you're currently trying to employ so that you don't have to admit that this is a real photo.
You said once every 90 seconds.
I said 90 minutes.
90 minutes is still very fast.
There's a lot 16 times faster than the Earth rotates.
Yeah, they claim there's a lot of satellites up there.
Yep.
And with every other satellite they supposedly send them there, the chances of it hitting that.
Yeah, it's called Kessler syndrome, and we're not currently in that in that scenario, because even though yes, there's like 15,000 satellites or something like this up there, space is very, very big. The average, and I calculated this once for a flat earther on a live stream, the average distance between satellites is like thousands of miles.
Okay. It would be, the sun would be on the opposite side of the Earth in this image, right?
I think that this is nighttime, yeah.
So it would be on the opposite side of the Earth?
Well, I don't know if it's exactly on the opposite side, or maybe they're approaching dawn. I don't know.
So my question is, if this is real and they're able to get these shots of the night sky whenever it's nighttime, you good?
I have a meeting.
All right,
it's tomorrow. It's tomorrow. I'm sorry. It's tomorrow. We're good.
Yeah, if it's nighttime and they're able to get these awesome shots, why is it only in this one image that it's visible?
This is a long exposure image.
Is that gonna be your cope every time?
That's just how that's just how optics work. It's how cameras work. This isn't cope. You should just learn how cameras work.
Why can't they show us more long exposure shots when they're up there?
So now you want more? I can go look for more if you want.
I want
Don
what
Petty
I want
is a astrophotographer. Like that's one of the, so he's good at this. Not every astronaut is. This is not like just some, this is not just like some random thing that is easy to do.
He also claimed that the technology from the 60s, it can't be replicated today.
That's cool. That's cool. You can keep repeating that. You can keep repeating that as you cope with the fact that they're obviously able to see the things that you wanted. By the way, here's another. Actually, let me just see long exposure photograph from space astronaut. If I just type this in, I guarantee I will find so many, and you've never even looked. Here. Here's one. You know how it's long exposure? Because you can see the after images of the stuff that's of like the stuff that's passing by in front of them. Let's go see if we can find another, shall we? That's the same one. Here's another one. This is one that we just looked at. This is from Don Petit. Very, like, obviously exactly what, actually, this is a different photo, but it looks like from the same time. Very high, very long exposure. Probably can see thousands of stars. Let's keep looking, shall we? Here's another long exposure. This time they didn't stabilize it, so you can see the star trails, right? You have to stabilize things in order to see the star trails, or in order to not see star trails. Here's another. You can see more star trails here. So yeah, there's plenty. You can just Google it, and you haven't.
The reason why I'm still skeptical is because these are all pictures. Why can't we get a video like this? A video.
Videos can't be long exposure. That's not how. Okay, do you understand that in order for a video to work, you have to take a video is just like a normal camera, and it takes 30 or more photographs per second, right? You understand that?
Yes.
Okay. Now, that means that each photograph can only take at most 1/30th of a second. Right? Long exposure means that the photograph takes a long time, like 1 second, 2 seconds, or longer. So you can't have a video with long exposure.
Okay, that makes sense. But I mean, I get that you can't see the amount of stars on a video as you would be able to with a photo with long exposure, but surely you can see some stars on a video with like taking a video. Surely you can see some. All I'm asking for is a video like that.
You've said all I'm asking for like a dozen times now, and then I've given you the thing that you're asking for. You just keep reaching and reaching until you find the one thing that I just can't find on a live stream.
The reason why is because
no amount of evidence would convince you. If I showed you a video showing stars in the sky from space, you still wouldn't accept it.
You and I both know that a photo, an image, a still image, is easier to fake than a video. I think we can both admit this.
An image is easier to fake?
Easier to fake than a video.
Why did you ask for a photo in the first place?
Well, to be honest, I've never seen these photos before.
Because you haven't looked. Because you're not curious. You're captured by your ideology.
So are you.
I'm sitting here providing you with evidence, by the way.
3 hours ago.
Just to be clear, you wanted a video of stars from space?
Hold on. I just need to see one thing. 3 hours ago, Soul, I think that was his name. He came up here and he gave you a document about. I think.
Oh, I don't have it up anymore.
Yeah, he gave you a document about. I think it was.
It was about microwaves.
Radio waves.
Microwaves. Yep, and I pulled it up and we looked at it together.
You disregarded what he said. Like
I pulled it up and we looked at it together, and he showed his ass to the entire live stream because he clearly didn't understand what he was reading. Now, you wanted a video of the stars from space, right?
Yeah.
Okay.
What is this?
A video of stars from space. This is from NASA's Gateway to Astronomy Photography of Earth contest. Or not, sorry, not contest. This is just, that's where the images come from.
What, is that the atmosphere?
Yeah, that's what you're seeing. You're seeing the atmosphere in the bottom half. Let me go find you more. Because there's plenty. And here's more, by the way.
I mean, that's cool, but
and now you're not gonna, now you're gonna be like, well, that's not enough to convince me. Look, all I'm asking for is, now what is it that you're asking for next?
well, why isn't it in a live stream?
There it is. All I'm asking for is it's a live stream.
I mean, well,
do you not hear yourself?
I do, but
this is like incredibly disingenuous. Every single time I give you the evidence, you're like, but what about? But what about? You just ask for more and more.
Look. A photo is easier to fake than a video, but a video is easier to fake than a live stream.
And you'd call the live stream fake too.
The ultimate proof that you could give would be a live stream with exactly what you just said.
One sec. So I just found a still from an ISS live stream showing some stars. Now I want to go find the actual live stream itself that comes from. And by the way, you've never looked at this. Why is it my job to do your looking for you when I found every single thing that you asked for with a simple Google? Every single thing that you've asked for with a simple Google, I've found, right? Oh,
I mean,
huh? What's? Sorry, I'm just scrolling through, scrubbing, if you will. I want to scrub to the night part. So obviously, by the way, found it. This is from an ISS live. This is from an ISS live stream. They're obviously over the day part of the Earth, but what are those two things off in the distance there? Those are stars. Obviously, this is barrel distortion, by the way. This is a very fisheye lens, but those are stars.
Yeah, that's cool.
Those space
what about at nighttime?
Every single time I give you what you ask for, the goalposts shift.
Well, if they're really up there,
every single time. Like, I don't know how you can't see that you're the one who is not willing to accept any evidence.
Listen.
Crazy.
If you get it at nighttime, and if you're right, if it's there, I'll just I'll accept defeat today and I'll move on.
Okay, let's see if we can go find it. Oh, that was easy. Hold on, I just want to make sure that this is a. Just gonna. One sec.
Person in the chat, I'm not gonna admit that it's a globe. I'm just gonna admit what I see on the screen.
Oh, okay. So nothing will convince you?
No, I mean, what would convince me?
There's only a few live streams that
what would convince me is if they really set me up there and I got to see it for myself.
Okay, I need to go find a live. I know that there is one live stream that points not directly down, but I have to find it because there's only a few live streams.
If I got to go up there with them and I saw it was really what they say it is, I would just renounce flat Earth. But like me seeing a live stream, me seeing a clip of a live stream, that's not gonna prove that the Earth is around. It's just gonna prove what Blitz is saying is really there. Like they have.
This is an animation. It was an animation because it's dark. It's hard to see. Let me speed this up. This is an animation, obviously. Here's the actual live stream. I just want to see if this live stream actually.
That's not looking. It's not looking good for you.
I want to see if this live stream actually doesn't point straight down, right? Because a lot of these live streams are just pointing down, and so.
Oh man.
Oh wait, hold on. Here's.
Oh no.
Here's one. Oh no, this one's pointing straight down too. Wait, do you think?
There's no stars.
This is pointing straight down. This is the ground.
No, wait, go back.
No,
go back.
That's the ground. It's just dark.
Oh, okay.
Yeah. This is just the ground. I think that this is just a fixed camera. See?
Odd how there's no city lights in that
Well,
image.
maybe they were flying over the ocean? Ever consider that?
Yeah, that's possible.
In
but
fact, they are flying over the ocean. You can
Possible?
see it in the bottom where they are. They're over the ocean.
Where? Where?
Off the southwest coast of Argentina, or Chile rather. They're down here.
I'm pretty sure Argentina has city lights.
They're over the ocean. They're hundreds of miles over the
So,
over
so
the
why
ocean.
why don't you skip to the part where they're over Argentina?
Well, that'll be daytime.
No, why really?
Yeah, because
So you're
look,
saying
look, it's entering daytime. Oh, what's that? It's daytime. Look, it's daytime, and they're over the ocean
all
now.
right, all right, yeah, you're right. But this is
And now they're over land. Look at the land. So this is a fixed camera.
Let's skip the daytime. Let's skip the nighttime. Let's skip the nighttime again over a continent.
Okay. Here, actually, they're gonna pass over like a really populated part of China. Here.
Okay, I did see some lights.
See? Look at all those lights. Oh wait, sorry, you can't see those. There.
I mean, all I would take is an opposite pointing camera at the night sky.
So I don't know if the ISS has a live stream for the pointing at nothing part of the ISS. I just don't know. But I did find you pictures, videos even, from space that would daytime, sure. Daytime videos from space, and you were like, not enough. But you're right, you found the one thing. You found the one thing where I can't find a live video at nighttime of a camera pointing at the stars from space. I can't find it, therefore the Earth is flat. You got me.
I'm not saying that would prove it's flat, but you know I'm not saying that. But you know, it's clear that I'm making you upset.
I mean, it's just you're being wildly dishonest. So like, yeah, that is kind of upsetting.
I think you were being dishonest earlier with Soul. You basically just dismissed all the evidence he brought up.
Well, I corrected him because he was wrong. That's not dismissing the evidence. That's just pointing out that you're wrong.
I
about something.
I didn't see the full debate. Did he actually admit he was wrong? Or are you just saying?
I don't know if he admitted that he was wrong.
Okay,
I suspect that he won't admit that he would never admit that he's wrong.
You're putting
in
words
fact,
in
you
his
haven't
mouth.
admitted that you're wrong, despite being proven wrong. Like now,
What I admitted is that you have a live stream of what what I admit is that you had pictures and you had a video and then you had a live stream.
Isn't it weird that you kept asking for different things when I kept giving you what you asked for? Doesn't that concern you? Like, shouldn't that bother you?
Don't you have like the intellectual honesty to admit that those things could be fake? They could be. Not saying they are,
Everything
but
could be fake. You could be a brain in a vat. That's not good evidence.
Right. So
that's not a good argument. That's not how we come to conclusions. You don't just get to keep moving the goalposts every single time that you get proven wrong, that your evidence is given to you. That's just not how we do science. It's not how we do honest investigations. But you're not interested in that because you're ideologically captured. I kicked him. He was here for long enough, and I'm way past overdue. We have been streaming for a long time. But don't worry, that'll go up on YouTube if you missed the beginning. So, y'all, I'm going to, let's read some super chats, shall we? Oops, that was me getting pushed away. From C-Bar with the $5, Blitz, can you please turn on super stickers? I don't always want to send a message with my donation. I'll work on it. I don't know how, but I will write it down. I'll tell myself, turn on super stickers. So I'll try to figure out how it works. From Skeet Sayer with the 5 Canuck bucks, we have no idea what clouds are going to do. Climate change has pumped a ton of humidity into the atmosphere. That's true. From Relax with Russell with the $5, the church is the institution we should trust the least. We know for a fact in church history they killed people who questioned and burned books. That's true. Or they sent them to house arrest, which is what they did to Galileo. From Stephen Andrews Shizin with the 7 Canuck bucks, that is an artifact of how the image was taken. The RGB channels were taken separately and the moon moves between them. Oh, that's a good point. From Christopher Sanford with the £5, the blue screen checkerboard is a scale to provide measurements for an experiment they were recording. That makes sense. From Ekapo with the €2, it's actually an ESA t-shirt. Oh, you got me. From Dr. Joe with the $10, is the dress blue or green? Never mind, that's the longest, most unpleasant nothing sandwich I've consumed in a while. I'm so sorry. I'm so sorry. You did great. You paid attention. You did great. From Jim Daniels with the $5. Another FLERF that doesn't know that we landed on the moon 6 times. Good grief. Yeah, it's a lot of times, right? From Pensive with the $20. Keep cooking. Very, very much appreciated. Love it. From Game Master Flash. Wow, I'm 32 and my voice just cracked. From Game Master Flash with the $10. Holy shit, please take more of my monies for having to deal with these ignorant jackasses. The India lander should have taken a glorious photo of the Earth from the moon so he could say that's fake too. Right, every single time he just asks for more and more. From Dr. Joe with the $5, please give the guests $2 of this to buy another SAT word so I don't have to hear disingenuous again. Oh no, flat earthers know that word. From Gretchen with the $3, I'd still give you $3.11 super chats every stream. I appreciate that. From Echopo with the €5, I hope for the future when we can grow brains for these poor folks. I don't know if that'll ever happen. From Necta with the $2, dude wants a magic roller coaster ride through space. It's impossible, right? From Garain with the $5, all I'm asking for is to be personally launched into space. Nah, my sensory inputs were fake too. Right? That's where it would end up. It'd be like, you put a video on the window. From Relax with Russell with the $2, actually I need to write down, just a note. Goalpost is on the Falcon Heavy. Holy fucking shit. True. Those goalposts are moving faster than the speed of sound. From Von Doodle with the £5. Excellent work today, Dr. Blitz. It's very much appreciated. I'm just going to double check and make sure I didn't miss any cash apps or any other donos. You guys are super generous. It looks like I didn't. So, just double checking for stuff. All right, so that's it for today. I should be live tomorrow. I'm not sure if I'll be live tomorrow for forever, for the normal time. That's why I ran a little bit late today, because I had some stuff to deal with. Or not some stuff, I just have to pack because I'm leaving. And so I will see you guys tomorrow for some more debates. We're going to postpone Ask a Physicist because, you know, we want to make sure that we get as much debate content before I go on vacation for 2 weeks. So guys, thank you guys so much for being here. Let's go see if we should raid anybody. Oh, by the way, before I let you go, if you like to support what I want to do or what I'm doing, try becoming a member on like YouTube, becoming a super fan on TikTok, a subscriber on Twitch. You get access to some nice debate notes perks, and also it's a good way to support me. Anyway, let's go see who we should raid. No one. You should raid no one. Everybody just go to my page and